A chapter which people are scared of, a chapter which people feel cannot be understood with some simple understanding. Believe me, this is one of those chapters which can be learned if you understand this in a structured manner, and this is exactly what we are going to do in this one short video of the chapter Indefinite Integration. People skip it because of its complexity, but understand, if you are able to structure it in a systematic manner, and once you have learned the concepts which you are going to learn in this particular chapter, the formula which you are going to learn in this particular chapter are used in definite integration, area under the curve, and differential equations as well. So entire calculus depends on this chapter. You just cannot skip it. Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of the chapter Indefinite Integration. In this video, we'll cover everything related to this particular chapter from your exams perspective. And along with this, don't forget that we'll consolidate all the learnings with a lot of previous year's questions. And yes, we are providing you the handwritten notes for your revision and the DPPs for your practice in the real-time environment. You can access all of this by clicking on the link given in the description, which will redirect you to our PW app, from where millions of students are preparing for different competitive exams at affordable prices and getting the success. So without any delay, let's see how should we understand this chapter in a systematic, structured and simple manner. This chapter is broadly categorized into 4 categories. The first 2 sections, which are integration by substitution and integration by parts, are simple and easy. But students get stuck here when they start solving questions based on partial fractions, and specifically the different miscellaneous forms, which we are going to understand in a very standard manner, in a very systematic manner. So yes, we'll go through everything in a very detailed manner. And that's exactly what is the motive of this particular one shot, to take you through everything, whatever is asked and needed to be understood from this particular chapter, which students find very complicated. We'll understand it in a very structured manner. You will experience it from this one shot. So let's get started, and first of all understand that why do we call it indefinite integration. As we have understood that in differentiation, for example, if I were to ask you that there is a function f of x, and f of x is, let's say, given as 3x squared plus 2, right? And if I were to ask you its derivative, what will you say? You would say, sir, that let's say if you are asked f dash x, which means the ddx of fx. I hope you are understanding it very clearly. So if I'm asked the derivative of f of x, which is ddx of f of x or f dash x, then of course it is given by 3 into 2, 6x to the power 1 plus 0. So that is the derivative of 6x. So here there was a function and it has a derivative 6x. Let's say I denote this function 6x as gx. Now, if this function f of x has a derivative which we are denoting by g of x, then will I or can I say that here the integration which is the opposite process of g of x, opposite process of the differentiation, would give you that integration of g of x should be f of x. Now there is a problem. What is the problem? The problem lies here that it comes with a concept of ambiguity. What is the concept of ambiguity? For example, here, forget f of x. Let's say there is another function h of x. H of x is also given as a function which is 3x squared minus 2. Now, instead of plus 2, let's say this is minus 2 or plus 5 or minus 3 or any constant here. Now, with this hx, if I find h dash x, will you not say that h dash x is also 6x? Because the derivative of minus 2 is 0. So here what you need to understand, that if somebody says that integration of g of x will be f of x, some of you might say that, sir, instead, integration of g of x as per their knowledge or understanding could be hx as well. Now, why are we saying that integration could be hx? Because if we are defining integration as a process which is inverse of differentiation, then if I'm differentiating this function and if I'm getting this function as its derivative, then the integration of this should give me this function. But I hope you are noticing the problem here. What is the problem? Most of you must have noticed that the problem is this constant. Sir, since this constant, when differentiated, becomes 0, and if we are integrating this function g of x, which is 6x, then on integration of 6x, I may get 3x squared. But what about this plus 2 or minus 2 or any other constant? What about that constant? Can we give a specific culmination or conclusion on this constant? No, we cannot. And that's a problem. So here what we do is we add a constant here and we say that this integration of g of x is clearly f of x but plus c. What is the meaning of plus c? Because this is indefinite. This cannot be found completely. The constant part here could be anything. And that's why I'll say that this kind of integration is called indefinite integration. It comes with some uncertainty. I hope you're understanding this part very clearly. There's no confusion on that. I hope now it makes complete sense that if I am integrating g of x, what is g of x? That is clearly 6x. So if you integrate 6x, that will be f of x, but that f of x could be anything. Simply 3x square is what will you get for sure. That is what you'll definitely get, because that differentiation of 3x square is definitely 6x. But 3x square plus 2 also has its derivative as 6x. 3x square minus 3 also has a derivative as 6x. So the integration of 6x would be 3x square for sure, but plus some constant. That constant we don't know. It could be plus 0, plus 3, minus 2, anything. So did you get that part? And that, because of the c only, we call it indefinite integration. So the concept of integration is derived from the concept of differentiation only. If you know or understand differentiation, then you can very easily conclude the concept of the formulae of integration as well. It is exactly the opposite in the inverse process of differentiation. Even all the formulae which we are going to discuss right now are absolutely, totally and clearly dependent on that expression only. That integration is inverse of differentiation. Did you get that part? Here, let's say if I ask you to differentiate x to the power n plus 1 upon n plus 1, what will be its derivative? Its derivative will be n plus 1 in the front times x to the power n plus 1 upon n plus 1. So, sorry, x to the power n plus 1 minus 1. So, you are finally left with n plus 1 are cancelled, and you are finally left with x to the power n. So, when you differentiate x to the power n plus 1 upon n plus 1, you get x to the power n. So opposite means the integration of x to the power n will be x to the power n plus 1 upon n plus 1. Did you get that part? I hope you are realizing it very clearly. One catch you all must realize and understand here is that n cannot be minus 1. N cannot be minus 1. Do remember it. So I hope first formula makes complete sense here, and you are able to digest this particular portion very clearly, that when x to the power n is integrated with respect to x, the formula says x to the power n plus 1 upon whole of n plus 1 plus the constant of integration. And we clearly understood here that n cannot be minus 1. Now, moving ahead towards the next conclusion, yes, if n is minus 1, then what happens? So in case if n is minus 1, the expression is x to the power minus 1, which is 1 upon x. 1 upon x, how do we interpret it? We know that ln x, log x, has its differentiation is 1 upon x. So we can say that integration of 1 upon x will be log x. But yes, log of modulus of x. Did you get that? And plus c is always going to be there as a constant of integration. Now, moving ahead with that, e to the power x. What a beautiful concept, what a beautiful expression, what a beautiful function it is. E to the power x, the derivative is also e to the power x. And similarly, here, let me just complete this part, although here, so we know that ddx of e to the power x is e to the power x. Hence, e to the power x when integrated should give you e to the power x. Plus a should be appended here. And I hope you know the reason very clearly. Moving ahead from here, the next expression is e to the power x is different from a to the power x. E is a Napier's constant. So a to the power x, where a is simply constant greater than 0, not equal to 1. In that case, we know that here, we knew that a to the power x, the differentiation of a to the power x is a to the power x ln a. So a to the power x upon ln a when differentiated gives you a to the power x. So from here, would I not conclude that the integration of a to the power x is equal to a to the power x upon ln a? Are you not noticing or realizing all the formulae of integration can simply be understood if you knew the concepts of differentiation? So the more versed well you are with differentiation or the formula of differentiation, with that much ease, you can deal with the formulae of integration. Similarly, what is the integration of minus cos x? Sorry, what is the differentiation of minus cos x? Sin x, because cos x is minus sin x. So minus cos x when differentiated gives you sin x. So here, I'll say the integration of sin x should be minus cos x. Did you get that point? Similarly, the differentiation of sin x is cos x. So the integration of cos x is sin x. I hope you have understood this integration of trigonometric function. Similarly, we knew that derivative of 10x is sec square x. So the integration of sec square x will be 10x. Plus c, if I forget to mention, I hope you will understand it by yourself. Similarly, the derivative of minus cot x is cos x square x. So on that basis, I'll say the integration of cos x square x will be cot x minus cot x plus c. We know that derivative of sec x was sec x tan x. So the integration of sec x tan x will be sec x plus c. Similarly here, if I proceed further, we knew that integration of derivative of cosec x is minus cosec x cot x. So derivative of minus cosec x is cosec x cot x. So here, integration of cosec x cot x will be minus cosec x. I hope there is no confusion on that. You must have remembered these formulae. It's simply a game of remembering and learning these formulae. If I apply chain rule and differentiate log of mod of sin x, do you remember it will be 1 upon mod of sin x? And in the numerator, it will be cos x. So cos x upon sin x gives you cot x. So the derivative of log of sin x is cot x. On the basis of that, would I not say integration of cot x will be log of sin x. This will prove through ILATE as well, but don't worry. Here I hope you are able to digest this particular part. In the same fashion, when you talk about derivative of minus of log of mod of cos x, that is tan x. So here I'll say integration of tan x is minus of log of mod of cos x. Here, I'll emphasize that rest of the formulae are very well learnt and understood by the students. These are some which you should remember. So whenever I ask you that integration of cot x, you should have it at your fingertips, log of sin x. Whenever I ask you the integration of tan x, you should have it at your fingertips, minus of log of cos x. Remember the signature, right? Now, moving ahead, what do we have next? What do we see next? The next result is here. If you differentiate log of sec x plus tan x by using chain rule only, you will get sec x. So here you need to understand that integration of sec x will be log of mod of sec x plus tan x. I urge you that you should remember and learn these formulae. Similarly, if I talk about another formula which says that derivative of log of cosec x minus cot x. If by simply using the chain rule you can prove it that this derivative is nothing but cosec x, and on those grounds you can conclude that integration of cosec x will be log of cosec x minus cot x. Similarly, here when you talk about inverse trigonometric functions, we knew their derivatives. For example, if I ask you the derivative of sine inverse x upon a, do you remember it is 1 upon under root a square minus a square x square. So here, whenever we are asked to integrate something like under root over 1 upon under root over a square minus x square, I without any hesitation would say it is sine inverse of x upon a. This is also something which I would ask you to remember. Not just that, some more based on ITF. Here, look at the next one. The integration of the derivative of cos inverse x upon a is minus 1 upon under root a square minus x square. So if you are dealing with minus 1 upon under root a square minus x square, that can be written as integration of this expression can be written as cos inverse of x upon a. And if I take this minus sign outside, I could write it as minus of sine inverse x upon a as well. Similarly here, if you pay attention to this part, 1 upon a tan inverse x upon a. Repeat here, 1 upon a is also there. So 1 upon a tan inverse x upon a, when differentiated, gives you 1 upon a square plus x square. So here I won't hesitate in concluding that integration of 1 upon a square plus x square is 1 upon a tan inverse x upon a. Don't forget that this is also a very crucial one, very widely used at a lot of places in a lot of questions. Now, let's look at the same. The next one, 1 upon a cot inverse x upon a, its derivative is minus 1 upon a square plus x square. So when you integrate minus 1 upon a square plus x square, it can be written as 1 upon a cot inverse x upon a. I hope you are able to relate all of these. There is no confusion on that. There are two more. For example, 1 upon a sec inverse x upon a is 1 upon x under root x square minus a square in terms of derivative. So its integration 1 upon x times under root over x square minus a square, its integration will be 1 upon a sec inverse x upon a. Similarly, when it is cosec, you simply replace it by a negative sign. So I hope you have made a great sense, a complete sense based on the understanding of all the formulae which you study in the chapter Indefinite Integration. Shall I move ahead from here? I hope there is no confusion on that. Now, in indefinite integration, something which you all should remember that whenever you are dealing with a rational algebraic function, what do I mean by rational algebraic function? A numerator upon denominator, two polynomials. Then remember, if the degree of the numerator is greater than or equal to the degree of denominator, then always remember that you divide the numerator by denominator first so that the denominator, so that the denominator has the higher degree and the numerator can be splitted as quotient plus remainder upon divisor. I hope you are understanding this property. And based on that, we now proceed with the process of integration. Just remember this, that whenever numerator has a higher degree, you divide it first by the denominator. Then your problem will become more simpler. Did you get my point? If you didn't, I'll explain it with a very simple example. Let's say here, if somebody asks you to integrate something like this, to integrate something like, let's say, x cube plus 2x square plus 1 divided by, the numerator is a cubic, I hope, polynomial, and the denominator is, let's say, x square plus 3 or 2, and this is what you need to integrate. So here my request will be simple. Let's see, the degree of the numerator is greater or even equal, then first of all divide this numerator by denominator, and then again rewrite this expression. I hope you understand this. And with that, then also after rewriting it in terms of that division, then you should integrate it. There you'll find it more helpful and more solvable. Here, some basic standard deductions which you have studied in differentiation as well. The same properties, few of those properties are applied as it is in terms of that sense only. For example, here, if a function is multiplied by a scalar and then you are integrating it, then of course, in terms of multiplication of product, you can take that scalar out and you can multiply that function f of x individually. The same property holds true in terms of addition and subtraction as well, the way we used to do in differentiation. So integration sign is also distributable over addition or subtraction. What does it mean? Let's say if I'm adding or subtracting some functions and then I wish to integrate it. So on addition and subtraction, the integration sign can be distributed. Integration of f of f1x plus integration of f2x minus integration of f3x and so on. So integration sign can be distributed over addition and subtraction. I did not say product. What do I mean by that? We'll talk about that. Don't worry about that. But here, if there are some integrations which you cannot directly find with the help of the formulae which we have learned, some integrals could be found through substitution as well. But before we move towards that substitution part, here are some integrals which cannot be found. Now, why can they not be found? Because there is no such function whose derivative could be this sin x upon x. So if I integrate sin x upon x, I cannot find a function. I hope you're understanding, because integration is opposite of inverse of differentiation. I hope you're understanding. So these are some expressions whose integrals cannot be found. If you want, you can take the screenshots of these examples. Few examples I have deliberately kept here. With that, if you have understood this particular part, now I'll talk about this part where I talk about integration through substitution, and that's where our chapter begins in actual terms. If you learn all the formulae, if you have by heart, if you have memorized all the formulae, then yes, this is the part from where your chapter actually begins. Integration using substitution. How? The idea is pretty simple here, students. Let's say we are given something like this. We are given something like this. Integration where f of g of x times g dot x dx. Then what we do is we replace or we substitute this gx as t. So by using the chain rule, will I not say that g dash x dx will be equal to dt? So this g dash x dx we replace by dt, this gx by t. So what we get is we get integration of ft dt. Did you get that part? And if we know the formula to integrate ft with respect to t, then we'll be able to solve this particular question. And in the end, again, I'll substitute t or I'll replace t by g of x. If you didn't get this part, I'll explain it with an example here. Two more conclusions you should remember, then we'll definitely understand it through an example. First of all, if whenever you see f of x, when f of x is integrated and let's say g of x is attained, in that case, if f of ax plus b is integrated, then g of ax plus b is attained, but here the coefficient of x, which is a, you need to divide that expression by a. What I'm trying to make you understand is a very simple result. Let's say if I ask you to integrate, let's say any expression, let's say we take sine of 2x plus 3. Now this is what I'm asking you to integrate. Now can you help me with the integration of sine x? We know the integration of sine x is minus cos x. I hope you understand this. So sine of 2x plus 3 when integrated gives you minus of cos of 2x plus 3, of course. And here the coefficient of x is 2. So you need to divide this expression by 2. So here you'll append a 2 here like this plus c. This is a very standard phenomena which you must have studied in 11th standard as well, in physics as well. And here also in 12th standard in mathematics, you do study this. Now, Similarly, there's one more result which you should remember. What is that? Here, this one. We know that 1 upon x when integrated gives you log of mod of x. So whenever you are given something like 1 upon ax plus b, then also you don't hesitate in writing its integration as log of mod of ax plus b. But again, you divide this entire expression by the coefficient of x, which is a. I hope there is no confusion on that front. You must remember, you will remember this result. Now, moving ahead from here, I'll try to give you more clarity on integration through substitution with the help of this particular example. Look at this question asked by JEE Mains in 2025. A lot of us are basically scared of integration psychologically. So in our brain, we have developed this, what should I say, fear of integration, that whenever we see a question of integration and any concept related to it, for example, definite integration, differential equations, area under the curve, we are prone to skip it. Because you're wired like this now, because there are a lot of concepts in integration and you get confused. And that's exactly my motive is going to be, that I'll keep it very systematic and structured so that you understand all of these in a very detailed manner, in a comprehensive, in a thorough manner. Look at this particular question. Again, a lot of students would simply give up on it. They won't even try to solve it. And that's the part where you need to understand that in calculus, a lot of questions look difficult. I repeat, they look difficult while they actually are not difficult. And a lot of questions can be done with some simple intuition if you just pay your attention, if you just observe the question, and if you just do some, hit and try like that. And believe me, with that, a lot of questions of calculus can be done. Look at this particular part. A very interesting question. It says integration of, what are we doing here? Integration of 1 by x plus 1 by x cube. That is what we are dealing with. But along with this, what do we have next? 23rd root of. So this expression is raised to the power 23. Okay, so I'll talk about that. But what are we given here? 3x to the power minus 24. So I'll say 3 upon x to the power 24 plus x to the power minus 26, which is 1 upon x to the power 26 whole raised to the power 1 by 23. I hope there is no confusion on that. And this is needed to be integrated with respect to x. And this is what we'll possibly get, which we'll compare later. But as of now, this is what I wish to integrate. Now here, if I wish to do a few things, what I'll suggest you to do is that, can I take x to the power 23 common from here? I hope we won't hesitate in doing so. So if I take x to the power 23 common from here, x to the power 23, x to the power 23, what will I left with? So if I take x to the power 23 common from here, x to the power 24 here, I'll be left with x only, because x to the power 23 I'm taking common. From x to the power 26, if I'm taking x to the power 23 common, I'll be left with x to the power 3, because 23 plus 3 is 26. So this is what I'm left with. But what I have done is I have taken x to the power 23 common. So 1 by 23, this power of x to the power 23 will leave you with x to the power 1. So outside, I'm left with x to the power 1 or something like 1 by x. Any confusions on that front? Did you get that part? I hope there is no confusion on that. Basically, what I've done is I have taken x to the power 23 common from here, but this entire expression was raised to the power 1 by 23. So when you take x to the power 23 or 1 by x to the power 23, then outside of this particular expression, you're left with 1 by x actually. Did you get this part? Now, if I multiply this 1 by x with this expression, what do I get? I'll simply do it here. So 1 by x into x will leave me with 1 by x square, plus this will leave me with 1 by x to the power 4. I hope there is no confusion on that. And we are going great. 1 by x square plus 1 by x to the power 4. And there you're left with 3 by x plus 1 by x cube dx. Of course, 1 by x cube whole raised to the power 1 by 23 dx. I hope there is no confusion on that. So I'm trying to do some arrangements. I'm trying to look at this expression in a little different manner so that I could be able to crack it. Now, if I simply use or try to use integration through substitution, look at this particular part. 3 upon x plus 1 by x cube. 3 upon x plus 1 by x cube. Let us look at this part. Okay. So if I look at this part where I'm saying 3 upon x plus 1 by x cube. And if I 1 by x cube, and if I ask you to assume it as a variable, let's say t, what I'm asking you to do is 3 upon x plus 1 upon x cube, let's assume it as a variable t. And if I differentiate both these sides with respect to t, with respect to x, what do we get? 3 upon x. It is basically 3 into x to the power minus 1. So x to the power minus 1, the differentiation of it is going to be minus 1 x to the power minus 2, which is minus 1 upon x square. So can I say this will be minus 3 upon x square? I hope there is no confusion on that. Similarly here, x cube goes to the numerator, it becomes minus x cube. So it will become minus 3 x to the power minus 4. Minus 4 comes in the denominator, becomes plus 4. So it will be minus 3 upon x to the power 4 whole dx is equal to dt. Now all I'm asking you to do is take this minus 3 common, and you'll see something very important here. If I take this minus 3 common from here, I'll be left with 1 upon x square plus 1 upon x to the power 4 dx. And when you take this minus 3 common from here, that goes to the other side and makes it minus 1 by 3 dt. Did you notice something very interesting here? Are you able to get something very important from here? Now my point is pretty simple, that I think our question is done. That's the only part which students find difficult. Rest of the work is really simple. So first of all, rearranging the question in a more simpler format. Second, then finding the appropriate substitution, the apt substitution. If you are able to find that, your job is done. Trust me, a lot of students must have realized by now that yes sir, the question looks done now. Why? Here 1 by x square plus 1 by x to the power 4 dx is clearly nothing but what? Dt, or minus 1 by 3 dt. So I'll rewrite this question as, of course, minus 1 by 3 will come into picture. Minus 1 by 3 integration of what? This dx can be replaced by dt, and this expression is t. So this question is t to the power 1 by 23. This question is t to the power 1 by 23 dt. I think I did not tell you what is needed to be done. Why do you not tell me? Why you don't tell me that what should be done now? I hope most of you must have realized that here it is simply minus 1 by 3. And do you remember integration of x to the power n? It was x to the power n plus 1 upon n plus 1. So here it is integration of t to the power 1 by 23. So it should be t to the power 1 by 23 plus 1 divided by 1 by 23 plus 1. Do you remember that? And of course, plus c is something I need to ensure as a constant of integration. So here, if I simplify this, I think it will be minus 1 by 3 times whole of t to the power 1 by 23 plus 1. It is basically 24 by 23. So this is t to the power 24 by 23 divided by, again, 24 by 23. So I'll keep this 24 here, but that 23 goes here. So this 23 goes here. I hope there is no confusion on that. And plus c is also going to be there. Now the other problem. What is the next problem? So the next problem is t is not t. T is actually something else. What is t? T is 3 by x plus 1 by x cube. So there comes a challenge. Now you need to replace this t by this, and you need to arrange your expression in such a manner that it matches with what we are given in the question. And so that you could compare it with this expression, and then you could figure out alpha, beta and gamma, which of course is not a difficult task. Most of you must have noticed what is going to be alpha, beta and gamma by observation only. If you still didn't get it, let me replace t by 3 by x plus 1 by x cube. So when you replace t by this, here I hope it is going to be negative of 24 into 3. So in the numerator it is minus 23 divided by 24 into 3 is basically 72. I hope you understood this very clearly. So it is going to be 72 times here. What do I see next? This t is raised to the power 24 by 23. What was t? 3 by x plus 1 by x cube. So it is 3 by x plus 1 by x cube whole raised to the power 24 by 23 plus c. Now it's simply a matter of rearranging this data and finding the values and comparing them and getting the answer. I hope most of you must have realized now that it is going to be minus 23 by 72. Okay, so this is going to be minus 23 by 72 times. What do I see next? Here, if I take the LCM is going to be x cube. All right, so the LCM is going to be x cube, and from here I'll simply write the numerator as well. The numerator is going to be, I hope you can see it very clearly, this is going to be basically 3x square plus 1. So the numerator is going to be 3x square plus 1. And this expression is raised to the power 24 by 23. This is raised to the power 24 by 23 plus c. So this is what we have gotten. Now let us match it with what we are given. So we are given as 3x to the power beta plus x to the power gamma, and this is something constant outside here. 3 is also there, minus is also there, so I made a mistake that I should have not multiplied this 3 inside, which made it look like 72. I should keep it like this only. So here I'll keep it like this only. It is minus 23 by 3 into 24. I think it will now match with what we are asked to write. Not just that, if I could rearrange it in a little more different format, I should not have taken the LCM. I should have simply kept them isolated, and I should have simply moved them in the numerator. So it will be 3x to the power minus 1. It will be 3x to the power minus 1 plus the next term will be 1 upon x cube, can be written as x to the power minus 3. Now I think it completely, totally and absolutely matches with our expression. Why and how? Let's have a look at that. So here if I match it with this, minus alpha upon 3 alpha plus 1. So I think this is minus alpha upon 3 times alpha plus 1. So from here I could crack that alpha is going to be 23. I hope there is no confusion on that. Here 3x to the power beta, x plus x to the power gamma. So 3x to the power beta, x to the power beta and x to the power gamma, which means gamma should be minus 3. Now further, if I want to clarify, it is alpha plus 1 upon alpha. Alpha plus 1 alpha means what? Alpha plus 1 upon alpha. So yes, these are the values of alpha, beta and gamma. Once you have cracked alpha, beta and gamma, what you are asked is alpha plus beta plus gamma. X was positive, x, y, z were integers. So I think alpha plus beta plus gamma means 23 minus 3 is 20. 20 minus 1 is 19. So your answer to this question would be 19. How do they make these questions lengthy? By simply adding a lot of calculation to them. Were you not realizing that this question was done at this step only? Once you've cracked the appropriate substitution, the job is done. But of course, they introduce a lot of calculation. So be very much cautious and alert, because in calculation, students commit some mistakes, and despite doing the question completely and correctly, they end up marking the wrong option. So beware of that. Here, there are some identities from trigonometry I wish to make you revise so that you can remember and learn them again, because these are the identities which are very prominently used in integration. How? Have a look at that. Usually, some questions give you questions like this. Let's say they give you sine 3x into sine 2x dx. Now, the problem is, if you don't know ILATE, even here ILATE is not advised. Let's say sine 3x into sine 2x. Now, this is a problem here. We know integration can be splitted over addition or subtraction, but here we are dealing with product. So how do we solve such questions? What I'll suggest is that multiply the numerator and denominator by 2. Even if you don't, here, look at this expression. Does it not match with something we are seeing in this third identity? Sin mx times sin nx can be written as half of cos m minus nx minus cos m plus nx. I hope you remember we have learned some identities. For example, sin a plus sin b, cos a plus cos b. Something like that is exactly what I'm asking you to remember from here. For example, the moment you see sin mx sin nx, this is what you're supposed to use. What is the advantage of it? The advantage is pretty simple. This is can be converted into something like this. So here I'll write it as integration, of course. With integration, of course, I'll say that 1 by 2 will also be introduced. That 1 by 2 can be kept here outside because it's a scalar quantity. So here sin mx sin nx is basically cos m minus nx. So it is going to be cos m minus n. So 3x minus 2x is x. Did you get that part? Minus cos m plus nx. So minus cos m plus nx. So m plus n means what? 3x plus 2x, that is nothing but 5x. And now most of you must have realized, yes, the job is done. Because integration can be splitted over addition or subtraction. So here I'll say integration of cos x minus integration of cos of 5x, which we know. And then I would be able to write it in the next step. So 2 steps it will take to solve this question if you know these identities. So my next conclusion is pretty simple, that learn these 4 formulae. By heart them, memorize them. In integration, you are going to see them getting used at a lot of places at a lot of times. Don't forget that these are 4 more formulae which you're supposed to memorize by heart or keep them at your fingertips. Not just in Trigo, but here in also integration, we use them at a lot of places and a lot of times. Now, moving ahead from here, what do we see next? Here, some more special integrals. Yes, I totally accept that integration is all about formulae. I totally accept that here, instead of understanding, you do understand, you can understand the derivation of these formulae. I can explain them within seconds. But the problem is, even if I do that, you are supposed to learn these formulae. You are supposed to memorize them. Because in the examination hall, you cannot derive them time and again. No, that's what you are not advised. This IIT JEE, these particular formulae, or a lot more, which are supposed to come in the upcoming slides, IIT JEE treats them as some very simple formulae which every aspirant is supposed to learn or memorize. Because these formulae are used at a lot of places. So here, I'll be showing you a lot of formulae, and yes, only request I have is that learn them, memorize them, because without that we won't be able to proceed further. So that's the challenge in mathematics in this specific chapter only, where you got to learn a lot of formulae. For example, here, when you talk about integration of 1 upon a square plus x square, do you remember this is something which we have discussed in the first 2 slides as well, that we have called it 1 upon a tan inverse x upon a. So this is something you must have remembered. But the other 2 ones matching to this one here, if I talk about integration of, what is happening here? If I talk about integration of 1 upon x square minus a square. So here, add it to the list of the formula which you are maintaining. If you are maintaining a formula book, and if you are adding these formulae to that, add these 2 as well. Very crucial one, and mark star on them. So here, integration of 1 upon x square minus a square is basically nothing but 1 by 2a log of x minus a upon x plus a, mod of course. If I could simply try and make you understand this through an example, let's say I am asked to integrate dx upon x square minus, let's say, 3. This is the expression which I'm asked to deal with. What I'll do here, of course, this 3, first of all, I'll write as under root 3 whole square, and this is now converted into 1 upon x square minus a square, which is 1 upon 2a. What is 1 upon 2a, students? A is under root 3, so 1 upon 2a is 2 root 3 times log of mod of x minus a upon x plus a. So it will be log of, what is x minus a here, students? X minus a is going to be x minus root 3, and x plus a is going to be x plus root 3 plus c, of course. So this is how you're supposed to deal with questions based on these formulae. And you cannot afford to forget them. You got to learn them. You got to memorize them. How do we learn or memorize? The idea is pretty simple. Make a formula book or write all these formulae of integration on a sheet, paste it in front of your study table wherever you study, and then revise them every day. In the morning, in the afternoon, in the evening, go through them, scan them, watch them, keep looking at them, keep observing them, keep repeating them, keep rehearsing them. That's the only technique. No other method will work here. And at this stage, no other method can work here. You won't say, or you cannot say that, sir, I'll practice a lot through which I will have these formulae at my fingertips. You had 2 years. Now, don't rely on that method. Learn them, memorize them. That's what you can do at this stage. Don't have any other assumption in your mind. Similarly, when you talk about another formula, here the problem was I had integration of x square minus a square. Now what I'm doing is integration of 1 upon a square minus x square. Some of you might say, sir, that this is this formula only. If I take negative sign common out of it, this will become this only. Yes, that's exactly what you should think, and you're going great, you're going correct. But if you don't take minus sign common, if let's say if you have taken minus sign common out of it, that minus comes here. So that minus becomes the power of log, and it becomes reciprocal of it. And that's exactly what has happened here. So x plus a, x minus a is basically becoming reciprocal of it here. So that can also be done. So if you could remember one of these, that's also fine. But if you could remember both of these, that's exactly what I'm expecting at this stage from you now. Please understand, if you want to master this chapter, which helps you in solving questions based on definite integration, area under the curve, problems based on differential equations, and of course, half of your calculus is dependent on integration. The remaining half, the rest of the half is dependent on differentiation. So yes, both are equally important. And if you want to have a good score, calculus is something which you always bank upon. You don't skip calculus, right? So to have a good command over calculus, you got to learn these formulae. I am begging you that you should learn these formulae if you want to have a good score. You don't have any other alternative. We don't have any other choice. Paste this formula sheet in front of your study table and revise it every day. That's the only possibility you're left with if you want to have a good command in the chapter integration. Yes, I can assure you that we can keep it simple. No matter how many times I'd explain this chapter, the only way to gain expertise in this chapter would be practicing it, revising it, memorizing it. Trust me, no other possibility is there. There is no other alternative. Now, moving ahead with the next set of rules, we see here few more formulae. Yes, when you talk about another special integral, then that is 1 upon under root a square minus x square. It is sine inverse x upon a. This is something which we have discussed. But depending on it, two more variants are there. One of them is under root over 1 upon under root over a square plus x square. It says log of mod of x plus under root of x square plus a square. What does it say? Let's take an example. Let's say any question matching to it can be taken. Let's say dx upon under root over, let's say 16 plus x square is what we are dealing with. Now, I hope you can clearly relate it with dx upon under root over 4 square plus x square. So, a becomes 4, x is x. So, I hope you can write the integration of this expression directly as log of mod of, what do you see inside the mod? X. So, x remains x, the variable, plus under root over x square plus a square, which is this only, which is under root over x square plus 16 or 16 plus x square, whatever you wish to write it as, plus c. So that is how you integrate this kind of an expression. Did you get that? Along with this, yes, there comes next, which is similar to this only, but here I was dealing with a square minus x square. Now we'll be dealing with x square minus a square. So again, two very crucial, very important formulae, which you got to learn. You cannot skip them. Here, if I simply try and make you understand them, then they are almost similar. I hope you can see them. And of course, if you simply pay a little bit attention, then yes, this formula is also something which you can learn or memorize, right? So if you find some symmetry by having some relation, you can learn these formulae. You got to develop your own methods. You got to learn your own techniques, and that's how you do them. Now, moving ahead towards the next set of formulae, yes, there are 3 more, there are some more, and there are a lot more. I'm not threatening you, I'm not frightening you, I'm not scaring you all. Please trust me. This chapter is all about formulae. So students get scared of learning a lot of formulae, and that's a problem here. I hope there is no confusion on that front. Now, moving ahead with the next set of formulae, this is even more, what should I say? More threatening. Yes, when you say that integration of under root over a square minus x square. So it becomes, these are the last 3 ones, which are a little complex ones. The other ones are really simple. And the best part is, they are the least important. JEE does not ask questions on it often. I'm not saying it does not at all. I'm saying not very often. So yes, some of you might think that these can be skipped. No, please don't do that. Imagine if a question is asked, and trust me, from integration, they already know this chapter is complicated for students because they cannot learn a lot of formulae. What if a question, a direct question on this formula is asked? And believe me, JEE does it. If the concept is critical, if the concept is very typical, if the concept is difficult, they don't complicate it further. They ask such questions directly. So whenever you see a chapter to be tough, please understand its basics. Because if you know its basics, the standard basic decent questions will be asked. And if the chapter is simple, tough questions will be asked. Are you understanding their psychology? So here, these are the 3 more formulae. I'll definitely make you revise them. Don't worry about that. But these 3 formulae are also what you're supposed to learn or memorize or by heart. I hope you will learn them. Now, moving ahead from here, let's see some important substitution. I had shown you these substitution while discussing the chapter differentiation as well. But there, I had insisted that more importantly than differentiation, we'll use the substitution in integration. And that's exactly what we'll be discussing here. The special integrals which we have just seen previously are actually or mostly derived with these substitutions only. For example, whenever you see an expression having somewhat like a square plus x square, don't hesitate in substituting x by a tan theta. Of course, when you make this substitution happen, you have to deal with other consequences as well. But of course, once you do that, your integration becomes simpler and you'll be able to integrate it with some simple approach or formula which we have learned. For example, whenever you see a square minus x square, you got to replace x by a sine theta. I hope you're realizing x when replaced by a sine theta, it is a square minus a square sine square theta. So a square can be taken common, 1 minus sine square theta, which is cos square theta. Then cos square theta can be written as something else. How and when? Let me try and help you with that as well. Again, if let's say a question asks you to integrate something related to cos square theta, I'm not saying this is the only problem you will be dealing with, but let's say it has a term in cos square theta. then how do you deal with? Again, this can be written as cos theta into cos theta, and I apply ILATE. No, that is not advised. If you know identities from Trigo, avail them, use them. For example, if I could make you recall something very crucial from Trigo, do you not remember cos 2 theta had 3 variants, out of which 2 are very crucial ones as far as integration is considered. Cos 2 theta we used to write as 2 cos square theta minus 1, and here 1 minus 2 sin square theta as well. Do you remember that? So from here, if I could rearrange this with this, would I not say that 1 plus cos 2 theta, 1 plus cos 2 theta whole divided by 2 can be written as cos square theta? Similarly, if I rearrange this with this, would I not say 1 minus cos 2 theta divided by 2 can be written as sin square theta? So if I ever see something like cos square theta, which I cannot integrate directly or it may get complicated, I'll substitute cos square theta by 1 plus cos 2 theta by 2. And I hope you're realizing how easy it would be to integrate this kind of an expression. The same I'll do with sin square theta as well. The moment you see sin square theta, substitute it by this 1 minus cos 2 theta by 2, because integrating that expression will be even simpler. I hope there is no confusion on that. Can we move ahead from here? I hope you are getting a great clarity on that front. Now we'll move towards different types of substitutions, different types of categories, different types of integrals, and we'll learn different methods that how can you solve questions based on them. For example, here, let's say this is something which we are given. Before I start discussing this, I'd like to give you more clarity on converting an expression into a perfect square. How? Let's have a look at that. For example, let's say I am given something like, let's say 3x square plus, let's say 7x plus 2. This is an expression, a quadratic expression I'm given. In integration based questions, there will be more chances of you being able to solve questions if you convert it into a perfect square. How do we do that? The idea says that first of all, to avoid confusion, take this 3 common. So if you take 3 common, what are you left with? When you have taken this 3 common, you're left with x square plus 7 by 3x plus 2 by 3. Now, what special have you achieved by doing this, sir? Trust me, have patience. We'll do something very interesting from here. What is that something special? Just have patience. Now, this 3 we are keeping outside. We are not touching it. But let's start dealing with this x square. So this x square, I'm treating it as a square. So a square plus b square plus 2ab or a square plus b square minus 2ab will be drawn. Depending on the sign here, it is plus 7 by 3x, so it will be plus 2ab. How do we do it? To make it look like plus 2ab, let me try and do that. So when I try and do that, I'll have plus 2. What is a? Sir, a is x. So what is b? So problem is, it is 7 by 3x. What you are writing is 2x. Okay, let me try and adjust it. What was it? Sir, it was 7 by 3x. But you have multiplied this term by 2. Why should you not divide it by 2? I must. So here, I'll divide it by 2. So technically, it is now balanced, because if it was 7 by 3x, 7 by 3x, because 2 cancels this 2. So ultimately, I'm left with 7 by 6 here. Did you get that part? And the moment you write a 7 by 6 here, you have gotten a clarity on b as well. What do I mean by b? A square plus 2ab. So what is the value of b? B is going to be 7 by 6. So if I have b, I should have a b square as well to convert it into a proper identity. So it becomes a square plus 2ab plus b square. But of course, this is not our property, which we can just, randomly play with. You need to understand, if you are adding something to it, you got to subtract something from it. So basically I have added square of 7 by 6. So I should subtract square of 7 by 6 from here. And it also has 2 by 3. So from that 2 by 3, I got to subtract square of 7 by 6. What is it? It is basically 49 by 36. So it is nothing but what? 49 by 36. So that's your whole expression. Sir, what have you achieved by doing this? We are simply and totally clueless. I am saying have patience for until the next step is attained or achieved. What I'm trying to say here is, let's keep this 3 outside. Yes, perfectly fine. What I do next is, have a look at this part. A square plus b square plus 2ab. How does it look like? A plus b whole square. So this matches with the result a plus b whole square, where a is x and b is 7 by 6. Okay, great. That's perfectly fine. What is next? Next is even simpler. Here, Can we not simplify this? To have a 36 here, I'll multiply numerator and denominator by 12. So 12 into 2 is 24, 12 into 3 is 36. 24 minus 49. So 49 minus 24, 9 minus 4, 5, 4 minus 2 is 2, 25 basically. Most of you must have cracked it. So it is basically 25 by 36, right? Now look at this part. Look at this part. How beautiful it is. Why am I saying beautiful? Because here, this entire expression I have worked as 3 times whole of this square, which is x plus 7 by 6 whole square minus square of 5 by 6 minus square of 5 by 6. Now, why am I saying this? Why am I saying this? I am saying all of this because here, please understand, is it not matching with x square minus a square? Is it not matching with x square minus a square? Now, if I ask you that if it matches with x square minus a square, then we had learnt some formula related to that. X square minus a square, x square plus a square minus x square, or even under root over a square minus a square, under root over a square plus x square, under root over x square minus a square. Not just that, here also under root over a square minus x square in the numerator plus x square in the numerator, x square minus a square inside and under root in the numerator. So yes, all of these formulae can be applied on an expression like these as well. But when? Only when you are able to convert these quadratics into perfect squares like these. Why? All I'm trying to make you understand is, let's say here I'm given a quadratic. I'm given a quadratic, 1 upon a quadratic in the denominator. Then now, as per my understanding, which I have built so far, will I not be able to write or convert this into x square plus a square form? And we know the formula of 1 upon x square plus a square. So by applying that, I can integrate this result. Did you get that part? I'll simply give you this idea with this example only. Let's say I need to integrate 1 upon 3x square plus 7x plus 2. Let's say I need to integrate 1 upon 3x square plus 7x plus 2, right? Now, we don't know how to integrate this. We totally don't know how to integrate this 3x square plus 7x plus 2. But do I know how to write this into a perfect square? Yes, we do have a result. What is that result? That result is clearly nothing but what? We can write this as 1 by 3. Since that 1 by 3 is a scalar, I'll keep that outside. Integration of dx upon, we have converted it as x plus 7 by 6 whole square, x plus 7 by 6 whole square minus, I think it was 5 by 6 whole square. Now, does it not match with something which you have learnt? Is it not matching with 1 upon x square minus a square? Even if this x has 7 by 6 with it, it clearly is not a problem for us. Are you not noticing that? So here, all I'm trying to make you understand is that if we have learned that formula, 1 upon x square minus a square, do you remember that formula? We have just discussed that formula here. We have discussed a lot of formulae, basically all these formulae, these ones, and before that these ones, Look at that, 1 upon x square plus a square, 1 upon x square minus a square. And which one are we supposed to use here? I think we are supposed to use 1 upon x square minus a square. So if we are supposed to use 1 upon x square minus a square, this is the one which we are supposed to use. 1 upon 2a log of x minus a upon x plus a. That's it. Did you realize that? So here, I will directly write it as 1 upon 2a. What is 1 upon 2a? See, 1 by 3 is already there into 1 by 2a. So what is a? X square minus a square. So 2a means 2 and a means 5 by 6 times log of mod of x minus a upon x plus a. So x minus a means x minus a. X minus a means x minus a upon x plus a. X plus a would mean x plus a. So are you understanding this very clearly? Plus c. In 2 steps, you can write the answer if you know the formula. Are you still not understanding? It is purely a game of learning the formula. No matter how many times a teacher explains integration to you, you would be able to understand this chapter only when you have learned the formula. So don't have this assumption in your brain that yes, you will be able to understand it as many times as you watch somebody doing it. Because trust me, it's a skill. Mathematics is a skill. Just like another skill, for example, swimming, driving. For example, you cannot learn swimming by watching me swimming. I hope you're understanding my point here very clearly. So if I am solving questions based on integration, I can demonstrate the approaches. I can tell you how to swim, but you got to enter into water and then you're supposed to learn swimming by yourself. It's a skill which you should master by yourself. And it can be mastered only when you start putting efforts by yourself, not by observing me time and again. So once you have watched the entire one shot, the only thing you should do is revise the notes which we are providing you and then attempt the DPPs and the PYQs. That's the only way to expertise or to have mastery in this particular domain, because it is simply nothing but a skill. Now, getting back to the discussion we were having, I hope simplifying this is a pretty simple task here. What you all must realize is 2, basically 3 into 2, 6, 6 gets cancelled by 6, so you're left with 1 by 5 here. Then you're left with log, and then here it is 7 minus 5, that is clearly 2. So 2 by 6, I think it is 1 by 3. I hope there is no confusion on that. So x plus 1 by 3. So in the numerator, it is x plus 1 by 3. In the denominator, what do we get? We get basically 12. 7 plus 5 is 12. 12 by 6 is 2. So it is going to be x plus 2. I hope there is no confusion on that. Plus c. If you wish to simplify it further, you can. But I would say this is going to be the answer. Did you notice nothing was needed to be done from here? If you know how to convert it into a perfect square. So whenever a quadratic is given, think of converting into a perfect square. Once you have converted it into a perfect square, then all you need to do is, please understand, some simple formulae are supposed to be applied. 9 formulae I am asking you to memorize. Which 9? I think 9 or 10 approximately. I'll say these 3, first of all, then these 3, and then these 3. So I think straightforward 9 formulae are supposed to be learned. If you learn these 9 formulae, you don't define these sum as the special forms. They are nothing but those 9 formulae only. Because here again, I'll convert it into a perfect square and then apply those formulae, that identity, that learning which we have just discussed. Because it will become what? 1 upon under root x square minus a square, or 1 upon under root a square minus x square, or 1 upon under root x square plus a square. And for these 3, we have learned some special integrals which are supposed to apply the way we have just applied in the last example. Similarly, it will happen here. Integration of under root x square plus a square, or it could become integration of under root x square minus a square, or it could become integration of under root a square minus x square. So depending on ABC, you would be converting it into a perfect square, and that's how you'll be getting the result. More importantly, 2 things are very crucial. Converting a quadratic into a perfect square and then applying the appropriate formula. For each of these three formulae, that means total 9 formulae are given. And trust me, without that, nothing can be done. Nobody can help. So you got to learn those 9 formulae. There is no other escape here. Did you get that part? Can I move ahead from here? I hope there is a great clarity built by you. Now, this is exactly what we have just discussed. Now, moving ahead with that part, how do we deal with this part where I'm having a linear and a quadratic? So something like this, linear upon quadratic, linear upon under root over quadratic, or linear into under root over quadratic. Now, how do we deal with this category of questions? That's exactly what we start discussing now. I hope there is no confusion so far. Even for this also, you just need to understand one more variance, and with that variance, you can deal with all these 3 category of questions. What is that? Let me have a look at that. Yes, here. This linear factor, which is px plus q, it could be there in the numerator or wherever it is. Here, with this expression, all you need to do is take your denominator, take your quadratic expression basically, wherever it is in the denominator or numerator or inside an under root sign, take its derivative and then multiply it by a constant and then add a constant to it. And then equate that value with px plus q. Now, what do I mean by that? I'll take any of these examples and just show it to you, whichever you wish to say. Let's say even this, or this. Let's say, to keep it simple, let me take this particular one, right? The same approach which I'm going to tell you could be applied here and here as well. Let me explain it in this context, right? Here, px plus q upon ax square plus bx plus c. Let's say I need to integrate this. So let's say in the numerator, this is 2x plus 3, and in the denominator, there is a quadratic, any quadratic, let's say 5x square plus let's say 2x minus 3. And this needs to be integrated. So what is the modus operandi? What is the operating procedure here? It's really simple, students. You just need to follow some standard steps. First of all, forget this question. Look at this numerator. What is it? Sir, it is 2x plus 3. So express this numerator as some constant times derivative of the denominator, which is 5x square plus 2x minus 3 plus another constant. Can it be done like this? Yes. How? Let's learn that. So here, of course, we have 2x plus 3 on the left hand side. And what do we have on the right hand side? It is lambda times 5x square is 10x, 2x is 2. And of course, this is what we have. I think nothing else is needed to be written, plus mu. Now, when you compare these two values, what do we get? I think it's a very simple result. Hi, wow. Here, 10x, if you compare the coefficients of x, it is 10x into lambda. Nothing else is there. So 10 lambda, here it is 2. So 2 is equal to 10 lambda, which means I can write lambda as 1 by 5. Similarly, what about the constant terms? Constant terms here will be 2 lambda plus mu. What about the constant terms here? It will be 3. And if I know lambda, which is 1 by 5, it will be 2 by 5. So if it is 2 by 5, mu will be 3 minus 2 by 5, which is nothing but what? 15 minus 2. 15 minus 2 is nothing but what? 13. So it should be 13 by 5. Now, once you have cracked the lambda and mu, what point I'm trying to make you understand here is that this numerator I'll express like this. Express like what? Express like this. What do I mean by that? 2x plus 3 I'll be writing as lambda times derivative of this. So lambda times 10x plus 2. Okay. So 2x plus 3 I'm writing as lambda times. Lambda is what? 1 by 5. So 1 by 5 times this 10x plus 2. Okay, so this is 10x plus 2. I hope there is no confusion on that. Plus mu. So this is lambda times this plus mu. What is mu? Mu is clearly 13 by 5. I hope there is no confusion on that. So this is 13 by 5. This is our numerator divided by the denominator. Divided by the denominator. What is the denominator? This is 5x square plus 2x minus 3. This is basically 5x square plus 2x minus 3, and this needs to be integrated. Now, why did we do this? Why am I doing all this? I hope most of you must have understood the motive. If some of you who couldn't realize the intent can see it very clearly, I divide this expression by this separately and this also separately here. So can I not write this question as 1 by 5 scalar times numerator, which is 10x plus 2 whole divided by 5x square plus 2x minus 3 dx minus, I hope you are seeing it very clearly, times, this is 13 by 5. So 13 by 5 times integration of 1 by this expression, which is 5x square plus 2x minus 3. Now, I hope all of you must have realized by now, this is something which we have already learnt. 1 upon x square plus a square, or 1 upon x square minus a square, or 1 upon a square minus x square, something like that will be created, and we know how to write that. This is exactly what we have just learned previously. What about this? This is even simpler. Why? Because if I let here in this particular integral, if I assume 5x square plus 2x minus 3 as t, would you not say that, sir, 10x plus 2 dx will be dt? And on that basis, I won't hesitate in saying that this is basically ln(t). ln(t) means what? ln of 5x square plus 2x minus 3. Did you get that? Sorry. I hope there is no confusion on that. This is what we already know. This is how it can be done. And that's exactly what you could do with the other two types of integrals as well, with this and with this. Are you now able to understand it systematically? So if you are able to understand it in a structured manner, you will be able to deal with this particular chapter in a very straightforward manner. Just learn the methods. For the second type, which one, students? For here, this one, for this one, px plus q upon under root ax square plus bx plus c. There also we apply the same method. And here, for the third type, what we do is here, when you have here any other integral, which is in what form? Which is having kx upon this, where what is k? Kx is a polynomial of degree greater than 2, as we have just discussed in the beginning of this lecture only. If you have a polynomial of higher degree in the numerator, then what you do is, first of all, you divide it by the denominator and then you solve it. What do I mean by that? I hope you know this very basic phenomena, that let's say I have something px upon qx, something like that is given to me in terms of integration. But what I know is that degree of Px is, let's say, greater than degree of Q of x, in that case, what do? In that case, first of all, divide P of x by Q of x. Don't start solving it straight away. Divide it by Q of x. So let's say when you divide, let's say, P of x by, let's say, Q of x. So you get a result. Let's say, R of x. And you finally get a remainder, let's say, H of x. I hope there is no confusion on that. Now, can I write P of x as Q of x into R of x upon H of x? And this H of x will have a degree either equal to or less than Q of x. I hope you understand the concept of remainder. It will be surely be less than Q of x, the degree of Q of x. So this Px, I'll be writing as Q of x into R of x plus H of x. This Px in the numerator can be replaced by Q of x times R of x plus H of x, and this whole expression is needed to be divided by Q of x, which I'll do separately in both of these expressions. Did you get that part? I hope there is no confusion on that. I hope you are understanding it very clearly. Now with that, I think I did not tell you what is needed to be done, because now let's say the denominator was quadratic. So this qx gets cancelled by this qx. This rx is basically a linear, and this is something linear upon quadratic, which you already know how to do it. We have just learned this. So are you understanding whenever you deal with these scenarios, how should you simplify this? So it's simply a game of simplifying them. But sir, what if instead of linear and a quadratic, a combination of quadratic and quadratic appears? So the third category, where the numerator has a quadratic, denominator has a quadratic, or quadratic into under root over quadratic, or quadratic into under root over quadratic. Why have I written them twice? I think there must be something wrong. There must be division kind of a signature must have been there. So forget this third one. Just look at these two. Right. So let's say these two are given. The third one must have it in the division only. So let me correct it here. So we are correcting it like this. Let's say under root over ax square plus bx plus c divided by under root over px square plus qx plus r. How do we deal with this kind of question? Approach is pretty simple. This ax square plus bx plus c, I hope you are understanding. The part which is not inside the under root, is written as the quadratic which was inside the under root times lambda plus derivative of that quadratic times mu plus gamma, where lambda, mu and gamma can again be found with the help of the simplification method through that comparison of coefficients of the same degree term, and that's how you can find it out. Let me try and make you understand it through one example here. Let's say we are dealing with this particular expression, the first one only. So this is ax square plus bx plus c upon px square plus qx plus r. How do we deal with this? Let's say integration of 2x square plus 3x minus 7 divided by, let's say, x square plus 3x plus 2 is needed to be done. So this is a case of quadratic upon quadratic. So let's say numerator has a quadratic, denominator also has a quadratic. So what I'll do is I'll simply write this numerator in terms of lambda times this quadratic. I think there is something wrong because there should have been an under root sign here as well. So let me correct that first. All I'd say is, yes, there should be division here, there should be product. No, it's fine. So yes, let's say this is also one of those categories. How do we deal with that? First of all, I'll say that here, what you need to do is that numerator and denominator, how do you relate it with? The denominator is what I'll start playing with. So first of all, I'll write numerator. So I'll do it here only. So let's say the numerator, what is it? It is 2x square plus 3x plus 7. This should be equated with three things. First of all, lambda times the denominator as it is, which is x square plus 3x plus 2, plus mu times derivative of the denominator. So derivative of denominator is x square is 2x plus 3 plus some constant, let's say lambda, mu, let's say I'll use another one, gamma. And now by comparing the same degree term, which means that here the second degree term is lambda, x square has a coefficient lambda here, and here it is 2. So lambda is nowhere else as far as x square is considered, the terms in x square. So lambda is going to be lambda x square is equals to 2x square, which means lambda should be 2. Now let's compare the terms with x, the coefficient x. So x as a coefficient is 3 here. So this is 3 on the left hand side, but here 3 lambda x will be there plus 2 mu x will be there. I hope you are understanding, but x is not what I need to write. So 3 lambda plus 2 mu is what I need to deal with. We know lambda is already 2. I hope you can see it very clearly. So 2 into 3 is 6. 6 means what? 6. So 3 minus 6 is minus 3. So minus 3 by 2 is going to be the value of mu. So mu is going to be minus 3 by 2. Similarly, I can find gamma as well by comparing the constant terms. For example, here, the constant term is 7 on the left hand side. The constant term is 7 on the left hand side, but on the right hand side, the constant terms are going to be 2 lambda, and then you'll have 3 mu, and then you'll have 3 mu plus gamma. So I hope you know lambda, you know mu. By having these, you can find gamma as well. Why did I do this? Now I can write this numerator into something like this. How and where? Let's have a look at that. I can write the numerator as lambda times x square plus 3x plus 2. So I'll be writing it as x square plus 3x plus 2 plus mu times the derivative of the denominator, which is 2x plus 3, which is 2x plus 3. Most of you must realize it now that why are we doing this? Plus the next term, which is gamma. Okay. This whole is needed to be divided by the denominator, which is x square plus 3x plus 2, which I'll distribute separately to all of these. So this is x square plus 3x plus 2 here. This is again x square plus 3x plus 2 here, and this is again here x square plus 3x plus 2 here. Now what we need to do is we need to integrate this entire expression. We need to integrate this entire expression. So integration of this with respect to x, integration of this with respect to x, integration of this with respect to x. Are you not realizing something like this we have already seen? Because this is what? This entire expression gets cancelled by this. So this is lambda, basically constant. So it is going to be lambda x. I hope there is no confusion on that. Here, this, if I assume as t, this is dt, because it is the derivative of this. So this is 1 upon t. So this is going to be ln t. So this is going to be mu ln t. What is t? T is basically x square plus 3x plus 2. Did you get that? And here, this is something we have already done. Gamma times dx upon x square plus 3x plus 2. Do you not remember 1 upon a quadratic or dx upon quadratic? This quadratic should be converted into a perfect square. So either x square plus a square or x square minus a square, or depending on the coefficient of x square, if it is negative, it would be a square minus x square, which is not in this case. But here, I hope you are understanding. This form can also be converted into something like that. And then you know the standard integrals, the standard formulae, and through that you can write the final answer. Are you understanding the same method is needed to be applied? You need to remember the pattern. You need to remember the approach. So if you could remember that logic, that modus operandi, you would be able to crack such questions with a lot of ease. Now, this is exactly what we have just discussed. Here comes another category of questions. How and when and where. See, whenever you are given something like this, 1 upon a cos square x plus b sin square x, or 1 upon a plus b sin square x, or 1 upon a plus b cos square x, or 1 upon a sin x plus b cos x whole square, or 1 upon a plus b sin square x plus c cos square x. So whenever you are having terms in sin square and cos square in the denominator, now what does the operandi says? What does the SOP says? It simply says that in the numerator and denominator, divide the entire expression by cos square x. Why? Because when you divide it by cos square x, what you are going to have is, let me try and do it here. Let me try and do it here with this expression only. So integration of, I'll just demonstrate it here. Why am I doing it? So let's say, what are we given? We are given integration of 1 divided by a times cos square x plus b times sin square x. Let's say this is what I need to integrate. So what is the method saying here? The approach is saying that divide both the numerator and denominator by cos square x. So when you divide the numerator by cos square x, I think I'll have this something like this. When you divide it by cos square x, it will look like this. When you divide this by cos square x, it will look like this. Now, why are we doing this? Most of you must have cracked it. Some of you who cannot see, I'll say that 1 upon cos square x is clearly what? Sec square x. So numerator will be sec square x dx. What about the denominator? Do you not realize that here cos square x eliminated, so you're left with a plus b sin square x upon cos square x is nothing but what? Tan square x. Now why are we doing all this? Because if I assume tan x as t, if I take or assume tan x as t, I think the job is done. How? Let me show it here. So let's say if I assume tan x as t, would you not say that, sir, sec square x dx will be dt. So if sec square x dx is dt, the numerator is sorted through substitution. So I'll say here, this is sec square x dx, which can be replaced by dt. And in the denominator, I'll say it is a plus bt square. It is basically a plus bt square. Do you not know a method for solving this? 1 upon a quadratic, or basically x square plus a square. This is simply a formula 1 upon a tan inverse x upon n. Do you remember that? By having that, you can finally find the answer. And ultimately, you can substitute the value of t, which was 10x. Don't forget to do that. Once you know that, I hope you can crack such questions with a lot of ease. That's exactly what I was saying here through this method. I hope there is no confusion on that. Now let's talk about the next form. Here, let's say sin x and cos x are given, but not their squares. Previously, in the last case, what were we given? Sin square x, cos square x here instead of sin x and cos x. But only sin x and cos x are given. In that case, remember that we had discussed a formula for sin 2 theta and cos 2 theta in terms of tan theta. What was that? Let me make you memorize or remember that. Sin 2 theta was 2 tan theta upon 1 plus tan square theta. And cos 2 theta was 1 minus tan square theta upon 1 plus tan square theta. That's exactly what we are going to use. So what I'll do is, I'll simply replace sin x and cos x by 2 tan x by 2 upon 1 plus tan square x by 2 and 1 minus tan square x by 2 upon 1 plus tan square x by 2 respectively. Why? Again, my why will be simple. Replace. Then, of course, once you have done this substitution, I'll show it to you here. Let me take an example. Let me take any of these examples. Let's say this one I will take to keep it simple. 1 upon a plus b sin x. Okay, so we have this integration. Okay, give me a second, students. Integration of 1 upon a plus b sin x. Let's say 3 plus 2 sin x. Now, how do we do it? There can be multiple methods, but the approach which we are trying to discuss here is saying that here, sin 2 theta, which is an identity basically, which we know how to convert into tan theta, is what I'll be using here. So I hope you remember dx upon 3 plus, do you remember the two ones which we have discussed, sin 2 theta and cos 2 theta? Do you remember sin 2 theta is 2 tan theta upon 1 plus tan square theta? That's exactly what I'll use here. So this 2 remains 2, but here let's say sin x. How will I write it as? I'll write it as 2 tan x by 2. So this 2 is multiplied here, divided by 1 plus tan square x by 2. I hope there is no confusion on that. First of all, I hope you're able to understand it. Why are we doing all this? You will understand it in the next step. See here. I'll say 1 plus tan square x by 2 is multiplied here. So here, this becomes in the denominator 1 plus tan square x by 2 into 3. So that is 3 plus 3 tan square x by 2. I hope there is no confusion on that. And here, what are we now left with? 2 into 2, that is 4 times tan x by 2. Did you get that part? I hope there is no confusion on that. Now what I do next is, this 1 plus tan square x by 2 goes in the numerator. So can I write it as sec square x by 2? I hope there is no confusion on that, dx. Now are again most of you not realizing this is again can be done with the help of substitution. How? I'll just simply show you the next step, then further or the rest is what I'm expecting you to solve. I hope you know how to do it. So here, tan x by 2. Let's say if I replace tan x by 2 by t. So what is the derivative of tan x? Tan x is basically sec square x. So it should be sec square x by 2. But x by 2, as per the chain rule, will become 1 by 2. Dx is equal to dt. So here I'll say that sec square x by 2 dx can be 2 dt. So here I'll have 2 dt in the numerator, and what do I have in the denominator? So the denominator is 3 tan square x by 2. 3 tan square x by 2 means 3t square. Then you have 4 tan x by 2, which is basically 4t, and there you have plus 3, which is a constant. Now you tell me, do you not know how to solve this? 1 upon a quadratic. Again, 1 upon x square plus a square, x square minus a square, or a square minus x square. Do you remember that? And there are 3 more formulae for that. Questions are lengthy. I totally accept that. Questions are going to be lengthy. 2 things basically play a very crucial role in integration, as I have been constantly mentioning that yes, first formulae, second approaches. For a specific category, a special approach is there, and you got to remember that. You got to learn that. That's the only way. So yes, it becomes, this chapter becomes more like biology, where you need to learn a lot, where you need to memorize a lot. I totally get that. But it uses a lot of logical concepts as well. It is not purely mugging up or claiming something. It uses a mixture of learning a lot of things and then applying them. So application is there. Logical awareness is needed here as well. I hope you're understanding that. Now, with that, if I move ahead towards the next part, what do we see? This is what we have already discussed. I hope you'd remember that. There is one more approach here. I wouldn't say that this is what you should remember. Simply learn what we have just discussed and apply that. Now, what do we do in these cases? Again, I'll say something which we were doing with quadratic upon quadratic. That sort of approach is needed to be applied. How? Let's learn it here. Let's say something like this is given. In that case, again, write the numerator as lambda times denominator plus mu times derivative of denominator plus gamma. Do you not think this will become something same as what we have just discussed in the case of quadratic upon quadratic, or quadratic into under root over quadratic, or quadratic upon under root over quadratic? Do you remember those three cases? And if that same scenario appears here, when a linear in cos x and sin x is given in the denominator and another linear in cos x and sin x is given in the denominator, then the numerator, what is numerator? Numerator should be written as, please understand, numerator should be written as lambda times denominator plus mu times derivative of the denominator. I hope there is no confusion, plus gamma. I hope there is no confusion on that. And again, when you replace numerator by this, then lambda times denominator upon denominator will leave with the denominator. Then mu times derivative of denominator upon denominator will give you ln(t). Do you remember that? And plus gamma upon, gamma is basically constant. So 1 upon this. And 1 upon this is exactly what we have just discussed previously here in this particular case. Do you not remember that? In this case, do you remember here? So I think we have had a great clarity on all what is needed to be done. I repeat this part if you have gotten confused. What I'll do here is, first of all, numerator will get replaced by this upon denominator. So numerator upon denominator, what does it become? It becomes this upon denominator plus this upon denominator plus this upon denominator. Do you remember that? Do you remember that? I hope there is no confusion on that. And if I am integrating this, this basically denominator cancelled. Lambda being constant, integration becomes lambda x. Here, integration when done here, denominator, and it is the derivative of denominator. So if I take denominator as t, this is dt. So 1 upon t, ln t. And of course, ln mod of t. What is t? T is the denominator. I hope you use there. What is 1 upon this? I hope you know 1 upon a linear in this is something which we have already learned, where you use the formula for sine 2 theta and cos 2 theta in terms of tan theta. All these three things can be done by you now. I hope so, because this is what we have just discussed. Sir, how do we find lambda, mu and gamma? By comparing the coefficients of sin x, cos x in the constant terms. By doing that, you can find lambda, gamma and the lambda, gamma and mu. I hope there is no confusion on that. Did you get that part? Can I move ahead from here? Now from here, I hope we can go ahead with the next part where we see a question based on exactly what we have been doing so far. So let's try and solve this question. It says 1 upon a square sin square x plus b square cos square x. This is exactly what we have just done few seconds ago or few minutes ago. I'll simply say that divide the numerator and the denominator by cos square x. So when you do so, the numerator becomes sec square x. So the numerator will be sec square x dx and the denominator will be sin square x upon cos square x is tan square x. So this is a square tan square x plus, what do we have here? B square cos square x upon cos square x is 1. I hope there is no confusion on that. Did you get that part very clearly? Now, moving ahead from here, what do I see next? I hope you know the result from here very clearly from here, that what I'll do is I'll take tan square x as t. So when you say that, let's say sir, tan square x is assumed as t. So when tan x I'm assuming as t. So when you assume tan x as t, we can very clearly conclude that sec square x dx will be dt. Do you remember that? This is basically a question asked by JEE last year only. I hope you can very clearly see that this integration becomes, in the numerator it is dt divided by a square t square plus b square. If you have any confusion on what I'm doing here, don't hesitate and take a square common from the denominator. That will make your problem even simpler. It will clearly match with what you have learnt as a formula. So here if I take this a square common, I'll have 1 upon a square outside as a scalar. Then you're left with dt, and here it is t square plus b by a whole square. Now from here, do you not know the approach? This is clearly nothing but what? 1 upon x square plus a square. You know 1 upon a tan inverse x upon a. Do you remember that? So here I'll write it as 1 upon a square is already there. Then what do we write here? 1 upon a. 1 upon a is 1 upon b upon a. That is a. So 1 upon b upon a means a by b. Did you get that part? Times tan inverse x upon a. What is x? X is t in this case. So x is t in this case upon a. What is a? A is actually b upon a. So it is b upon a, and a goes in the numerator. So it goes like this. I hope there is no confusion on that. Did you get that part? Now, only thing you need to do is replace this t by what? Replace this t by 10x. And through that, you got the answer. Through that, you got the answer. How and why? Let me try and show it to you here. It is basically nothing but what? A gets cancelled by a. So what you're left with is 1 upon AB. I hope there is no confusion on that. Times tan inverse of A tan t by B. Did you get that part? Now, if I start comparing things, I think I have the values now, because if I compare it here, I think what do I get? Let me compare it here. So we are getting AB as 12. We are getting AB as 12 because 1 upon 12 means what? 1 upon AB. So AB is basically 12. And we are getting A upon B. We are getting A upon B as 3. I hope there is no confusion on that. So from here, I'll say that A is basically 3B. Do you all agree with this? A is basically 3B. So if I replace A by 3B from here, A is basically what? 3B. So 3 into B, that is B squared, which is 12. So from here, I'll say B should be plus minus 2. I'll say that B should be plus minus 2. No other data is given to me. Tan inverse this. So I think tan inverse B should be plus minus 2. B should be plus minus 2. Now, I think we have A and B both, because if B is plus minus 2, this will help me in concluding A is plus minus B 3 into plus minus 2, that is plus minus 6. So I think we have cracked A and B. Now, what is the next part? So the next part is A sin x plus B cos x. Its maximum value is what we are asked. A sin x plus B cos x. What is A? A is plus minus 6. So plus minus 6 sin x plus minus. What is B? B is 2. Plus minus 2 basically. So plus minus 2 cos x. Do you remember in Trigo we have discussed a formula for it? Are you realizing integration plus trigonometry they have done here? And that's what they do. That's what IIT JEE loves doing. They merge concepts from different chapters. And that's how you solve questions based on integration. So what do I do next? I'll simply find its maximum and minima. Do you remember A cos theta plus B sin theta lies between negative of under root of A square plus B square to plus of positive of under root of A square plus B square. So that will be its maximum value. So we are asked its maximum value. It will always be less than under root over A square. 6 square is 36 plus B square. 2 square is 4. So 36 plus 4 is 40. So under root 40 will be my answer, which is given in option A. Did you understand how easy these concepts are? How interesting these questions are? If you know the basics. Can I move ahead from here? Now, going ahead, what do we see next? So next part is ILATE, integration by parts. Now that's again something which is something really amazing. So far we have been discussing a lot of things related to substitution and a lot of different forms and how do you deal with them. And their forms, their approach, their methods, their standard technique, along with the formulae which are to be applied there should be learnt. So far you must have realized it. Now how do you deal with ILATE? So ILATE has its own proof which you can prove through differentiation, which I'm skipping right now. I'm giving you the direct formula and how to apply this. So here, if two functions in terms of product are given, then the way product rule was being applied in differentiation, in the same fashion, we apply product rule integration as well, but the formula, the approach remains different. How? See, here, first function and second function. So integration of this is given by first function into integration of second function minus integration of whole of derivative of first into integration of second. Did you get that part? This is something which you must have been memorizing since 11th standard if you're preparing for IIT JEE. Now, here, this is how they are written verbally, but I'll say that choosing the first function and second function plays a very crucial part. And that is done based on ILATE rule. That is done based on ILATE rule. Now, what does ILATE say? What does it suggest? It says that when ILATE is needed to be used, it says that I stands for inverse, L stands for logarithm or logarithmic, A stands for algebraic, T stands for trigonometric, and EH stands for exponent. For example, let's say integration of e to the power x into sin x is needed to be done. Then it has an exponential function and it has a trigonometric function. So what I'll do is between trigonometric and exponential function, I'll give priority to trigonometric function, which means this trigonometric function will be chosen or treated as the first function, and this will be chosen as the second function. So this becomes u and this becomes p. And I hope you know the further process. How do I integrate it? First function as it is, integration of second minus integration of whole of differentiation of first into integration of second. And that's how you keep doing it. Did you get that part? I hope you're able to understand how should you use ILATE. Simple thumb rule which you should follow while solving question based on product of two functions which are supposed to be integrated. This is exactly what I'll try to give you or make you understand through this example. Here, let's try and solve this particular question, right? So how do we solve this? The idea is pretty simple here, students. First of all, I'll try to deal with this 4x cube, right? So how do I do it? Can I take this minus 4x cube? Can I substitute with something? Okay, let's try and do that. What is the advantage of this? We'll work it out later. But as of now, let's say I take minus 4x cube as t. I hope I can do that without any hesitation or problem. So when you do so, what you get is minus 4x cube, right? So the derivative is going to be minus 12x square dx is equal to dt. Sir, what is the point? Why are we doing this? Let's try and do this. Let's see what advantage do we achieve by having that. So here, when something like this is being done, first of all, I can very clearly see, first of all, that this is x to the power 5 into something, right? So this x to the power 5, I'll rewrite this entire question first of all. So here, I'm given x to the power 5. Can I write that x to the power 5 as x cube into x square? I hope I can do that. And here, what I have is e to the power minus 4x cube dx. That is the question. I hope no changes are being made. X to the power 5, I have written as x cube into x square. And this is e to the power minus 4x cube. Did you get that part? I hope there is no confusion on that front. Now, why are we doing this? Please understand, I'm thinking of a substitution where I'm replacing minus 4x cube by t. So here, if I ask you what will be the value of x cube, all of you must realize and say, sir, it is going to be minus t by 4. Do you all agree with this? That if minus 4x cube is t, x cube is going to be minus t by 4. Now, why are we doing this? Here, this x cube, I am replacing by minus t by 4. So minus 1 by 4 comes outside and you're left with t inside. Great. This x square dx, I hope makes complete sense here, that here x square dx can be replaced by dt upon minus 12. So here it is going to be dt upon minus 12, which means this minus and that minus gets cancelled, and here left with 1 by 12 as well, because minus minus plus. But here, because of that, x square dx now can be replaced by dt upon minus 12. So minus 12 is already there. I'll write it as dt. But one more thing I should be writing or taking care of is that e to the power minus 4x cube. But minus 4x cube was t. So I'll be writing it as e to the power t. Did you understand this substitution, students? I hope there is no confusion. Now, sir, this looks like that we need to use the ILATE rule here. I hope you are understanding it. But how do we decide the first function and second function? Don't forget that we have this feature of ILATE. I think I am seeing two functions here. Which two, students? I think we are seeing an exponential function and an algebraic expression. So which one should be treated as the first function? Which can be vanished easily. So I think it is nothing but algebraic. That should be your first function. Exponential should be your second function. So if I simply treat this as your first function and this as your second function. So here 12 into 4 is basically nothing but 1 by 48. So we have received that. Now e to the power minus 4x cube into fx, something like that I'll receive here. So I'll have 1 by 48 outside multiplied by first function as it is. So t remains as it is times integration of second function. So integration of e to the power t will be e to the power t minus integration of derivative of first function. So derivative of first function means what? Derivative of t into integration of second function. So integration of e to the power t will be e to the power t and dt. I hope you are understanding it. But here only I could say, or I would say, that e to the power t when integrated gives you e to the power t only. I hope you are understanding it here. So can I not directly replace an e to the power t here? And of course, as a part of habit, don't forget putting over c here. Did you get that part? Now, if I were to simplify this, what will I receive here? I think e to the power t can be taken common. So when you take e to the power t common, what are you now finally left with? So when you take e to the power t common, it is e to the power t by 48 times whole of what? T minus 1. Now, if I again substitute t back here, so t was minus 4x cube, so it is e to the power minus 4x cube divided by 48 times e to the power minus 4x cube minus 1. Have you understood it very clearly? So what were we asked? We were given e to the power minus 4x cube upon 48 times f of x. So this expression in the curly brackets is nothing but f of x. And by comparing it here, I think we have received, okay, I'm really sorry, I'm making a mistake here. I am really, really sorry for that. T is not e to the power this. I'm really, really sorry for that. T is basically what? T is minus 4x cube. So it should be minus 4x cube. Let me just check it here. Yes, so it should be minus 4x cube minus 1, which clearly matches with option A. So I'm really sorry for that. I hope you don't commit such silly errors. Right, now let us move ahead towards the next part. This is something really interesting. This can be proved with some simple efforts. More importantly, what I'm asking you to do is, I'll of course prove it, don't worry about that. But as soon as you see a question which involves e to the power x into something, let's say, whenever you see a question of integration which has e to the power x into something, then try to split that expression into a sum of two functions where the other function is the derivative of the first function. Why? Trust me, if you are able to do so, if you are able to split that expression into a sum of two functions where one of the functions is derivative of the other function, in that case, you can directly write the answer as e to the power x f of x. Of course, you are going to learn this result. This is something JEE loves asking. JEE asks a question on it every year. This is that short question which you got to remember here from here. So I'll say yes, don't forget, this is a very crucial concept, amazingly crucial or a vital concept from your JEE's perspective from this particular chapter. Now, how do we use it? I'll definitely show you how do we use it. Let's take an example. This here is the proof of this particular expression, which I'll definitely show you. Here, have a look at that. E to the power x fx into e to the power x f dash x. This is how I can write it. I'm not touching it at all. I'm keeping it intact. But I'm integrating this expression where I'm keeping it as first function, this as second function. So I hope you remember. How do we do it? There is no confusion on that front, I believe. I'm really sorry. This, I think, is opposite here. They have mistakenly written it like this. This should be the first function here. This should be the first function here. Let me write it like this. And this should be the second function here. So when you do that, what result do you attain? Have a look at that. First function as it is, integration of second function minus integration of differentiation of first function into integration of second function. Now, do you not realize that this expression and this expression are absolutely identical, which means now you're finally left with e to the f of x into e to the power x. Did you get that part? I hope there is no confusion on that. Always remember, so whenever you wish to evaluate an expression of this type, where e to the power x times whole of a function plus its derivative is given, then don't hesitate in writing your answer as e to the power x times the function f of x plus c, of course. So whenever you see a question having e to the power x into something, you need not integrate. The job is breaking that other factor as a sum of two functions where second one is derivative of first one. I hope it is understandable. Now, if it is understandable, let us try and use this in this question asked by JEE Mains in 2025, and it will become such an easy question if you know this concept. Let's have a look at that. Here, I can very clearly see that, sir, e to the power x is given, brilliant, and something also we are given. Now, can we crack that? We can. How? Let's have a look at that. I think we can crack it if I could break this entire expression into something where one of the part is the derivative of the other part. Let's try and do that. Through my intuition, I can clearly see that, sir, if this is treated as f of x, then I may get this as f of x, f dash x, because product rule can be applied on f of x and sine inverse x, and a lot of things can be attained by this. Through my observation and intuition and experience, I can say so. And once you start solving questions based on integration, you would also be able to conclude such scenarios. Let's have a look at that. So here, I'm beginning my discussion with a very simple phenomena here, or a discussion here, that let's take this part x sine inverse x divided by under root over 1 minus x square, right? This is what I'm assuming as f of x. Let's say we call it f of x. Now, when you differentiate it, what do you get? I think I'll get a lot of results, but by observation only, I think I need to keep it like this, that sir, let us treat this part, which part, students? This part as one function and the other part as second function. So to have more clarity here, can I write this f of x in a little different format to keep it simpler for you to make it understandable, right? So I'm writing f of x, this portion only, as x upon under root over 1 minus x square times sine inverse x. Can we do so? Now let's try and find f dash x. So when you try to find f dash x, what result do you get? Let's have a look at that. So I think f dash x, derivative, product rule on derivative, first function, second function. I hope you understand. Derivative of first function. So derivative of x upon under root 1 minus x square. I hope nobody is getting confused with that. You know how to differentiate it. Now there you need to understand that actually there are three functions. Because in x upon under root 1 minus x square, you're supposed to use the quotient rule. But if you don't want to use quotient rule, you can use the product rule also in a little different manner. So let's try and use that. How? Have a look at that part. All right. Okay, so the process is pretty simple here, students. You choose this as px by qx, or simply, chain rule you can apply. So whichever you wish to do, or product rule basically. So how do we do it? I think the product rule will be more beneficial, but be more cautious, be more alert. How do I do it? See, now basically I'm seeing three functions. What do I mean by three functions? See, I can write it as, or rather if I keep it as 2 only, because then also I'll have to add it. So I'll keep it as 2 functions only, so that you don't get confused. So this is my first function, this is my second function. So if I keep second function as it is, which is sine inverse x, right? I'll find the derivative of x upon under root 1 minus x square, right? So I'll do it. I'll try to do it. So how do I do it? This I'll do here. So even if I use the quotient rule, because that is more helpful here. So denominator should have this square. So square of under root 1 minus x square is nothing but what? 1 minus x square. Now the derivative of numerator. So derivative of x is 1 into denominator as it is, which is under root over 1 minus x square, minus, pay attention, numerator as it is, and then derivative of the denominator. Now please understand, here I'll apply chain rule. So here denominator is what? Under root over 1 minus x square. So this is 1 minus x square to the power 1 by 2. So it will become 1 by 2 times 1 minus x square to the power 1 by 2 minus 1, which is basically 1 by x square to the power minus 1 by 2, which is 1 minus x square. I hope there is no confusion on that. And then I need to differentiate 1 minus x square as per the chain rule. So derivative of 1 minus x square will be minus 2x. It will be minus 2x. That minus 2x I'm writing here. I hope no confusion on that front. You are able to understand this completely and totally. Now, if I multiply the numerator by 1 minus x square, let me simplify this part first. I'll come to this part, but I think here this needs to be simplified, otherwise it will become more confusing to you. So here, if let me write f dash x later. I am differentiating this part first of all, this function only as of now, because this will create a lot of trouble. So I'm doing it separately. I hope you're understanding it. So here, if I take this 2 is there, minus x is there. So when minus x multiplies to this minus 2x, it becomes plus 2x square. So here it will be plus 2x square in the numerator, and denominator has, okay, this 2 and this 2 are cancelled. So it should be simply plus x square only. Right, I repeat, this 2 and this 2 are cancelled. So it is plus x square in the numerator, and denominator has under root 1 minus x square. Now what you must understand is this under root 1 minus x square and under root 1 minus x square, when LCM is being taken, it leaves you with plus 1 minus x square into 1 minus x square. Both are inside the under root. So it leaves you with 1 minus x square like this. I hope no confusion on that. And in the denominator, you have 1 minus x square raised to the power 1. Now, I hope you can see it very clearly. This and this are cancelled. So you're left with 1 divided by 1 minus x square to the power 1 plus 1 by 2, which is 3 by 2. So the derivative of this entire expression, this first part only, first function only, is going to be 1 upon 1 minus x squared to the power 3 by 2. So here I'll be writing it as the derivative of fx, which is f dash x, as derivative of this, which we have worked out as this, which is 1 upon under root over, 1 minus x squared to the power 3 by 2 into second function as it is. Second function is sine inverse x. So I'll write sine inverse x here only. So that's your sine inverse x plus first function as it is. The first function is x upon under root 1 minus x square times derivative of second function. Derivative of sine inverse x is 1 upon under root 1 minus x square. So when you multiply this with this, it is under root over 1 minus x square into under root over 1 minus x square will leave you with this. So this is f dash x, which clearly matches with this, part. So if I could highlight this part for you, I'd say that if this is treated as f of x, you wouldn't hesitate in saying that this is basically f dash x. And if I have fx and f dash x as the sum times whole times e to the power x, then the answer is e to the power x times f of x. Then the answer is e to the power x times f of x. That means g of x is going to be e to the power x times f of x. What is e to the power x? E to the power x is e to the power x. But what is f of x? F of x was this. Do you remember that? So I think we have cracked g of x. So g of x will be written as e to the power x times f of x. And what is f of x? It is x times sine inverse of x whole divided by under root 1 minus x square. So far, with these much efforts, you have cracked this g of x. This looked like a question on integration where I didn't do any integration at all. Did you realize that part? So the moment you see e to the power x, this is what should come to your brain. Now what do we do next? So the next part is we are not asked g of x, we are asked g of 1 by 2. I think this is what I leave up to you. In place of x, replace x by 1 by 2 and you can get the answer, which is an easy task, which I need not teach at least. So I hope you can do that. Not a difficult task. You all should be able to do that. So here, this is what I have told you so far. I hope you'll remember this result. A very, 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 very crucial result. If you have gotten confused in any part, do watch this solution again. You will get a great clarity. I hope we can move ahead from here. Now, this is something where you need to result this as a direct result. I'll directly give you the result where we use recursion now. So this is, these are two formulae, e to the power ax sin bx and e to the power ax cos bx. They have their own standard formulae. If you could learn them, do remember them. And if you don't, do remember this entire approach, which I am definitely sharing with you right now at this stage. What does it say? I'll definitely show you the proof. So e to the power ax sin bx, let's say we call it I, right? So here, e to the power ax I take as the second function, sin bx I assume as a first function, right? Now, how do I proceed with that? See, first function as it is, integration of second will be e to the power ax upon a minus integration of derivative of first. So sin bx, when it differentiated, gives you b cos bx, and integration of second means what? Sin e to the power ex by a. Now here, this b and a being the constant come outside here, and you are left with cos bx e to the power ax. So the entire expression is 1 by a sin bx e to the power ax. I hope you can see it here. Then from here, b by a comes outside, and you are left with integration of cos bx e to the power ax. Now, this part I again start solving. Which part, students? This part. I am now dealing with this part, cos bx into e to the power ax. So if I rewrite this as cos bx into e to the power ax, would you not say this clearly looks or matches with this? And then again I apply this ILATE rule here. Now by again having this rule here, what I do is again first function, second function, and I do that whole process again. Sir, this means you will keep doing it infinitely? No, this just one more time. So when you do it one more time, the whole process takes place. And when you do that, what you end up achieving is you get this, what you have already achieved, minus b square by square times a sin bx into e to the power ax dx. This is exactly nothing but what we have started with, which is I. So I hope you're understanding the meaning of recursion, that here, this I, which was I on the left hand side, is something I. So this b square by a square minus I bring on the left hand side. It becomes I plus b square by a square I, and there I get some expression. And then when I simplify this, a square plus b square by a square, and I take it on the left hand side. So this is the final value of I which I attained, which we were trying to figure out. Again, we couldn't integrate it, but here I could use the recursion, and through recursion, I could write I. What was I? I was basically nothing but this expression's value. In the same fashion, you can find this value as well, but I'd suggest that if you could, and if you should, and you must, remember this one as well. I hope you would. Now, moving ahead with the next result. These are the two results which we are keeping in front of you. Now we come to the next part where we'll be learning integration through partial fractions. Now, what are partial fractions? Let me just simply give you an example. I'll take this one only. Let's say I'm given a question. I'm given a question where I need to integrate x plus 1 upon x minus 1, x minus 2, x minus 3. I'll take it very clearly. So let's say I'm given a question where I need to integrate x plus 1 whole upon x minus 1, x minus 2, x minus 3. So x minus 1, x minus 2, x minus 3. And let's say this needs to be integrated. Now most of you must be saying, sir, it is linear upon cubic. This is what you haven't taught us. So here in this case, we must have it in the factorized form. If we have it in the factorized form, partial fractions suggest you a very interesting thing, that here, take this entire expression, which is what? Which is x plus 1 divided by x minus 1, x minus 2, x minus 3. This as a upon, a is an arbitrary constant which I'll figure out, a upon the first factor in the denominator, which is x minus 1, plus b upon the second factor, which is x minus 2, plus c upon the third factor, which is x minus 3. Any confusions on that, students? Did you get this part? Now, when you take the LCM on the left hand side, what you get is x minus 1, x minus 2, x minus 3. What you do on the right hand side, you get a times x minus 2, x minus 3 plus b times x minus 1, x minus 3 plus c times, I hope you are understanding what I'm doing, x minus 1 times x minus 2. This whole expression is equal to x plus 1 divided by this x minus 1, x minus 2, x minus 3. Now I can cancel these two denominators and then I can compare the numerators. So the numerators which we are going to compare, I think I can do it in this very step only to avoid some time, to save some time. How can I avoid some time? To save some time. Now let's start comparing things. How do we compare it? First of all, I'll try to find a. Now, how do I find a? If I replace x by 1, this and this will get eliminated and I'll get the value of a. So since it is an identity, it should be satisfied by all the values of x. So I'm replacing x by 1 on both the sides. So when you replace x by 1, 1 plus 1 becomes 2, and there you're left with a times 1 minus 2, which is minus 1, 1 minus 3, which is minus 2. Minus 2 minus 1, 2, 2, 2, that's 1. So a we receive as 1. So we have gotten the value of a, which is 1. Any confusions on that? Now, how do I find b? If I replace x by 2, I could crack b. So when you replace x by 2 on the left hand side, 2 plus 1 becomes 3. 2 minus 2, 0. Here, b times 2 minus 1 is 1, 2 minus 3 is minus 1. And this is 2 minus 2, which is 0. So b we have received as minus 3. Any confusions on that? Now let's try and find c. So to have c, can I not replace x by 3? I hope you are understanding it. So when you replace x by 3 on the left hand side, 3 plus 1 is 4. 3 minus 3 is 0. 3 minus 3 is 0. Here it is 3 minus 1, that is 2. And 3 minus 2 is 1. So 2c is 4, which means c should be 2. Sir, why did you do all this? What is the point of doing all this? Have patience. In the next few seconds, you will realize the complete point. Now, have a look at this part. The question, which was x plus 1 upon x minus 1, x minus 2, x minus 3, this was needed to be integrated. We have been able to write it as this plus this plus this. Did you get my point? And if I replace the values of a, b and c, what are a, b and c? Sir, a is 1. So I'll replace a by 1 here. I hope you are understanding this. B by minus 3. So I'll replace b by minus 3 here. So I'm replacing b by minus, what is wrong here? B by minus 3 here. And c by 2. And we'll replace c by 2 here. I hope I need not tell you. The integration of 1 upon x minus 1 is, integration of 1 upon x minus 1 is log of mod of x minus 1. Do you remember that? Plus, or rather plus I should use minus. So minus 3, keep it aside, 1 upon x minus 2, integration of it is log of x minus 2. So it should be minus 3 times log of mod of x minus 2 plus 2 times 1 upon x minus 3. The integration of it should be log of mod of x minus 3 plus the constant of integration. Did you understand this? This is how easily you could crack such questions. I hope it is comfortably understood by you all. So that is the meaning of partial fractions, and that is how you solve such questions. I hope it makes complete sense. This is exactly what they have also done. So this is what they are trying to tell you. But sir, this is one of the scenarios. What else should we remember? I'll give you all these scenarios. We have noted these scenarios down as well here as well. But I'll simply try and give you and tell you these scenarios through some examples. Okay. So let's say one of the question has this kind of a question. Dx upon, okay, forget question based on integration. First, let's learn partial fractions, right? So let's say I have to convert this, let's say 1 upon x minus 1 into x minus 2 whole square. Sir, in that case, what are we supposed to do? The partial fraction theory says that here I'll be writing this as a upon the first factor, which is x minus 1, plus b upon. Now don't write x minus 2 whole square. First of all, write x minus 2 once. So if I write x minus 2 once, it will be x minus 2, and then c upon this factor, which is appearing twice, x minus 2 whole square. This is what you're supposed to do. Did you get that part? So if, let's say, x minus 2 is appearing 3 times, if it was cube, then I'll say x minus 2, then x minus 2 square, then x minus 2 cube. I'll write it thrice like this. Did you get that part? Sir, these are the linear factors. What if we have the quadratic factors? In that case, what you should do is, we have kept it simply here as well, that here, let's say we have here, this may confuse you all, I think. So here I'll write it only. So let's say this is an example. I hope you must have understood it. Let me take one more example here. So let's say here I have a factor which is x square plus 2, and the other factor is, let's say, x minus 1. So let me write the linear factor first. So for linear factor, we know it should be simply a constant upon that linear factor. But for a quadratic factor, you should write the numerator as a linear factor, which is bx plus c divided by that quadratic factor. Did you get that part? What if the quadratic factor had repeated twice? For example, if power 2 was given, what will you do? We know if it is repeating twice, I'll say that here I need to use another linear dx plus e divided by this quadratic appearing 2 times, x square plus 2 whole square. Are you able to understand how should we solve it now? Simply by comparing the terms, the degrees and coefficients, and then a, b, c, d, e can be found. But this kind of a complicated problem will not appear. Your problems will be restricted to either here or the case where x square plus 2 is appearing only once. But you should remember all these cases, all these scenarios. Can I move ahead from here? I hope there is no confusion on that. So if you have partial fractions, let us try and solve this question. How do we do it? So this question looks like a question on trigo. Let's try and use that here. 2 minus 10x upon 3 plus 10x. First of all, here the best thing is going to be convert this expression into sine and cos. So let's simply begin with this part that I'll be writing it as integration of 10x. I'm writing as sine x upon cos x. So it will become 2 cos x minus sine x, right? And what about the denominator? Sine x upon cos x. So this should be 3 cos x plus sine x, right? This is what we need to integrate. Do you remember this? That here I'll be writing it. Let me do it this here. I'll be writing this numerator as, I hope you remember the numerator. What is the numerator? 2 cos x minus sine x as lambda times the denominator. So lambda times the denominator means what? Lambda times 3 cos x plus sine x plus mu times the derivative of the denominator. So the derivative of the denominator means what? 3 cos x plus sin x. The derivative is going to be minus 3 sin x plus cos x. Now here I need not write another gamma here because there is no constant term neither in the numerator nor in the denominator. So I need not introduce another variable or a constant here. I hope you're understanding why. So if I compare the coefficients of sin x and cos x, I would be able to crack lambda and mu, or maybe equations in lambda and mu. So how do I do it? I'll simply write it like this. If I compare the coefficients of cos x, so this is 3 lambda and here it is plus mu, and the cos x coefficient is 2 here. I hope there is no confusion on that. Now let's compare the coefficients of sin x. So this is lambda here, and what do we have? I think it's simply mu here. I hope I'm not missing anything. We are comparing the coefficients of cos or sine. I think previously we have compared cos, so this is 3 lambda plus mu. I think we were great. Now I'm comparing the coefficients of sine, so it is lambda minus 3 mu. Yes, so it should be minus 3 mu. And we are comparing the coefficient of sine, so it should be minus 1 here. I hope it is understandable totally and completely. So if I multiply this equation by, let's say, 3, so it will become 9 lambda plus 3 mu is equal to 6. And I write this as it is and I add this to that. So lambda minus 3 mu is equal to minus 1. So when I add these two equations, I think I'll have mu are cancelled. 9 plus 1, 10 is equal to 5. So 10 lambda is 5. So lambda is, I think, 1 by 2. Because 10 lambda is 5. So lambda should be 5 by 10, which is 1 by 2. If I replace that lambda, let's say here, I hope we can do that. There is no confusion on that. So it is 3 by 2. 3 by 2 goes there. So it is 2 minus 3 by 2, which is also 1 by 2. So I think we have received mu as well as 1 by 2. Any confusions on that? Now, if I treat this numerator as, let's say, nr for a while and denominator as dr for a while, then we have basically converted numerator upon denominator into the numerator I have kept as it is. I am writing this numerator as lambda times denominator. What is lambda? Lambda means 1 by 2 times denominator upon this denominator plus mu times, mu is again 1 by 2 times derivative of the denominator. I'm denoting it by d dash, dr dash. That is the derivative of the denominator upon denominator. I hope you're understanding. Numerator we have been able to write as lambda times denominator plus mu times derivative of denominator upon denominator. So that denominator I have split it to this as well as this, and I have replaced lambda and mu as well, but I have written it in a shorter format so that we can end up saving time, and that's what I would expect from you as well. Now what I do next is can I cancel, or rather what are we asked? Integrate this, then integrate this, then integrate this. So you would say, sir, denominator upon denominator means what? 1. So it is going to be x. What about this? This is also very interesting. If you are getting confused at this stage, I'll keep it more clear. Our question will now look like 1 by 2 integration of 1, which is x. So this should be x plus here. It should be half of integration of, I'll show it here, half of integration of derivative of the denominator. This is the derivative of the denominator, minus 3 sin x plus cos x. So this is minus 3 sin x plus cos x. Although you should be able to understand this at this stage, but if you are not able to, I'll show it very clearly. And the denominator is 3 cos x plus sin x. So the denominator is 3 cos x plus sin x dx. This is what I'm trying to tell you, that if I assume the denominator as t, so this is basically dt, numerator dx is dt. So this is dt upon t, which is ln t. So my expression would be 1 by 2 common x plus ln t, mod of t. What is t? This denominator, which is mod of 3 cos x plus sin x plus constant of integration, which is c. I hope there is no confusion on that. And now when I start comparing the values, I think I'll have a lot of values. For example, a I think is the coefficient of x, which is clearly nothing but what? 1. Because 1 by 2 is outside, we also have this 1 by 2 outside, so we need not worry about that. Then ln of, so does ln have also a coefficient? No. Ln of beta sin x plus gamma cos x. So beta should be 1, gamma should be 3. Beta should be 1 and gamma should be 3. Do you have any confusions on that? What are we asked? I think alpha plus gamma upon beta. Alpha plus gamma upon beta. This is alpha, which this was basically alpha, right? So alpha plus gamma upon beta, which is 3 upon 1, and that should be 4. Alpha plus gamma upon beta, yes, 1 plus 3 by 1, which is 3 plus 1, which is nothing but 4. I hope easy and simple it was. And you must realize this is exactly what we have done previously. So are you now able to get more comfortable with this concept integration? I hope it does not look very difficult or tricky to you at this stage. Now, when I move ahead from this, I think now we are going to deal with some more forms. For example, let's say whenever you deal with something like this, f of x plus 1 by x times whole of 1 minus 1 by x square, then what do? I'll simply suggest some substitutions now, which are ideally done. So I'll not be giving you some questions. I'll be suggesting you different forms that if this appears, then do this. If that appears, do this. I'm giving you a pattern list now. So first pattern in that list would be, if whenever you see something like this, f of x plus 1 by x times whole of 1 minus 1 by x square, then if you do this, if you substitute x plus 1 by x by t, I hope you are realizing the derivative of x will be 1, 1 by x will become minus 1 by x square, dx dt. So this dx will become dt and your question will be ft dt, which you know how to solve. I hope you must have understood this. And ultimately, after getting the final solution, replace that t again by x plus 1 by x. So that is the first learning. Remember that IIT JEE does ask questions based on this pattern. I hope you wouldn't forget that. There is one more pattern. Let's say if I have f of x minus 1 by x, 1 plus 1 by x square dx. In that case, replace x minus 1 by x by t and it will become 1 plus 1 by x square dx dt. So understand, if you could create such kind of scenarios, you should avail these substitutions. That's what I'm trying to give you. Not everything can be taught through examples or questions. I can give you a direct formula or a pattern that if something like that appears, you should do this. So when you're maintaining that pattern list, add these examples, add these scenarios to your pattern list, that if this happens, then this should be done. And then again, the approach will remain same. If it is in sine, then sine cos, the same approach will appear. That is not my concern. My concern is to make you understand that are you understanding these substitutions, right? Now, moving ahead with that, this is also a very interesting one. Here, I'll say that whenever you see a quadratic in the numerator and a biquadratic in the denominator, where you have terms in x to the power 4, x square only, and of course a constant term. In that case, divide the numerator and denominator by x square. Then what? Then I'll tell you, when you do so, what you achieve is, in that case also divided by x square only. I'll show it here. Let's say, let me take an example. Okay. So let's say we are given a question where we are told that x square plus 1 divided by x to the power 4 plus, let's say, 2x square. Instead of 2x square, let me take something else. Let's say 3x square plus 1, right? So that is a question given to us. Now, why am I saying that you should divide it by x square? So let's say I'm dividing the numerator and denominator by x square. What do I achieve by doing so? So when you divide numerator and denominator by x square, it becomes 1. This becomes 1 by x square and this becomes dx. But what happens with the denominator? The denominator becomes, this becomes x square. This becomes 1 by x square. I hope there is no confusion on that. And this becomes 3. Now, what I am trying to suggest to you here, I am giving you a very important, very crucial, very amazing result, which says, look at this part, look at the denominator. Look at this denominator only. Look at this denominator. If you could create something out of it, which when differentiated gives you something like this, then your job is done. Now go back to what we have just discussed in the last slide. I think I can get this if I have this x minus 1 by x. So if I could convert this into x minus 1 by x, sir, what are you talking about? How can you convert it into x minus 1 by x? Have patience. Let's try and do that. So here, if I take you back to somewhere else, would you not say that if I tell you that what is the square of x minus 1 by x whole square, you would say that, sir, it is x square plus 1 by x square plus 2 into x into 1 by x, which is 2 only. So from here, would I not say that x square plus 1 by x square will be this minus 2? So that expression which we are dealing as a question can be written as, in the numerator, it will be 1 plus 1 by x square dx whole divided by, I hope you are understanding what I'm trying to say here is that x square plus 1 by x square can be written as x minus 1 by x whole square. But when you expand this, this is x square plus 1 by x square plus 2. I need a 2. So from this t, let's borrow a 2. So when you borrow a 2, you're left with 1. So what you have achieved or attained by doing so. Have patience. That's the key. So here, if I now substitute x minus 1 by x by, let's say, t for a while. X minus 1 by x by t for a while. I hope I can say 1 plus 1 by x square dx will be dt, and the job is done. And the job is done. Why am I saying so? 1 plus 1 by x square dx has become dt divided by this. What is it? This we have assumed as t. So it is nothing but t square plus 1, which I can write as t square plus 1 square. Are you not seeing it as 1 upon x square plus a square? Do you know it as tan inverse 1 upon a tan inverse x upon a? And then don't forget to replace t by x minus 1 by x in the end. The last two steps which you must have done infinitely many times by now. Did you get this part? Shall I re-explain this? I hope you're building a great clarity now that in this pattern of question also, you're supposed to do the same. But here in the numerator, now you'll get x minus 1 by x square. So in the denominator, have x plus 1 by x whole square. I hope you're understanding why. So that vice versa is needed to be done. Now we talk about reduction formulae. IIT asks questions on reduction formulae as well. How do they frame questions on it? Let's have a look at that. For example, let's say sine x to the power n we are given. And I need to write its reduction formula. So how do I do it? I'll first of all write this sine x to the power n as a product of two factors, where I'll split it into sine x and sine x to the power n minus 1. This I treat as a first function and this I treat as a second function. Now by using ILATE or integration by parts, what I'll say is that first function as it is, integration of second function plus integration of derivative of first function into integration of second function. When you finally solve all of this, ultimately when you do this, what you receive is this kind of an expression times integration of sine x to the power n minus 2. Now please understand, if I am assuming this as, let's say, in sine x to the power n, the integration of it, I'm treating it as in. So integration of sine x to the power n minus 2, can I not write that as in minus 2? So when you finally simplify this by having this entire expression, you get the value of in as sine x to the power n minus 1 cos x upon n plus n minus 1 times in minus 2. So this is a recursion formula. Again, you're not able to simplify in, but you're able to write in terms of in minus 2. For example, sine x to the power 4 is needed to be figured out. So what I'll do is, this is what I'll write, where I'll replace n by 4, and here n minus 1 by n times I 4 minus 2, which is I2. Then I'll find the integration of sine square x. So that's how you keep on going in deeper. That's the recursion formula. Similarly, the same formula can be derived on cos x to the power n as well. But rather, this which you will have with your notes, the same formula for tan x as well, I'll try and make you understand the entire phenomena or the approach through an example. But I hope you're understanding how do you use the recursion formula. How should you avail this particular part? Two terms will be given. For example, in tan x, you don't do it like this. In tan x, you avail it with the sec square x. What I'm trying to say is that exactly what I'll explain with this example. This example was asked by JEE in 2017. What does it say? They are defining tan x to the power n as in, where n is greater than 1. And then they are saying that I4 plus I6 is this. Then find the value of a comma b. Okay, let us write I4 and I6. Then we'll try working out what should be the value of that. So I4 plus I6 is what I'm starting to work upon. What is I4? If this is in, I hope I need not hesitate in saying what is I4. I4 will be 10x to the power 4. What would be I6, students? Sir, I6 would be 10x to the power 6. I hope you got this part very clearly. No confusions on that. Now, I hope you understand that here, this integration, if it could be splitted over addition or subtraction, it could be merged as well. Why am I doing this? I don't know, but I can see something which you might not be able to right now. But if you are, then do write it in the comment box. So integration of 10x to the power 4 plus 10x to the power 6 dx. That is what we are supposed to do. Now, why did I do it? Let us take 10x to the power 4 common. So when you do that, what you achieve here is this. Integration of 10x to the power 4, I have taken common, and then I'm left with 1 plus 10 square x dx. Can you help me with 1 plus 10 square x? I hope you know something. What is 1 plus 10 square x, students? It is sec square x. So it will be written as integration of 10x to the power 4 times sec square x dx, and I think the job is completely, totally and absolutely done. Why and how? Because you would now say that, sir, substitute 10x by t so that you can have sec square x dx as dt. So what will you have here? You will have integration of t to the power 4 sec square x dx is dt. What is t to the power 4? Integration of t to the power 4. It should be t to the power 5 by 5 plus c. I hope there is no confusion on that. So when I talk about t, what was t? I think t was 10x. So my answer will be 10x to the power 5 divided by 5 plus c. Now what were we asked? We were told that it is a 10x to the power 5 plus bx to the power 5 plus c. So what I can say is that what is a? 10x to the power 5, the coefficient of this is 1 by 5, so a should be 1 by 5. But I cannot see any term in x to the power 5, so that coefficient, the coefficient of x to the power 5, which is b, as per my logic should be 0. So I think we have a and b both 1 by 5 comma 0, and that's exactly what we were asked. 1 by 5 comma 0 is what we are given in option B. Any confusions on that? I hope you have gotten a great clarity on that front as well. No confusion on that part. And that's how we culminate this session here at this stage. Before you leave or stop watching this video, do listen to this part as well, where I'll say that yes, I hope you must have watched this one short video on indefinite integration and you have brought a great clarity on this. You should have watched it completely, because with this, you could get a great clarity on the upcoming chapters as well. Indefinite, after indefinite, we have definite, we have area under the curve, we have differential equations and a lot more. So yes, there we use these concepts. So you should have watched it. And if you are treating this as a difficult chapter, if you're considering it as a difficult one, then do remember, if it is difficult, easy questions will be asked. Then why should you not study it? I hope you're understanding my point. If easy questions are going to be asked, having a good observation only, that will help you a lot on this or from this chapter. And don't forget, in this one shot, we have tried covering everything whichever is asked from this particular chapter through apt or sufficient number of illustrations, examples, and previous year's questions, which might have consolidated all the concepts which we have tried explaining in this particular video. And don't forget, all these notes will be provided to you by clicking on the link given in the description. You can click on it, it will redirect you to our app from where you can access these notes at absolutely no cost. The way you are watching these videos. And don't forget, along with these videos, we are also providing you the DPPs for your practice in the real test environment, in the real-time test environment on our PW app only, which is an amazing platform from where millions of students are preparing for different competitive exams at no cost, at affordable prices, and at some courses at no cost. And they are getting the desired results as well. Don't forget that. So I think this is sufficient for the day. Let's meet in the next video. Thank you so much.